All right, good morning. To try to keep us kind of on schedule, if we could get seated. All right, Frank, get them all in the seats. All right, good morning. I'm Amy Grundon, and I'm here to welcome you all to this Center of Regulatory Excellence, Excellence for Regulatory Science and Agriculture workshop in incorporating the benefits of precision application into risk assessment and risk mitigation of pesticides. This is a very important and timely workshop in a critical area of impacting global food security, and as you'll hear from our panel of expert speakers this morning, is again a really important area for us to be concentrating on. So on behalf of the leadership for the College of Ag and Life Sciences at North Carolina State University and the organizing committee, I bid you welcome. Dr. Denisha Sathkarli also brings her greetings. She wishes she could be here, but knows that we'll all be in good hands with our organizing committee, our facilitators, with Dr. Rebecca Dunning, who's our chief facilitator here. So you'll be hearing from her in a little bit. She's in the back there. And Carrie Rogers and Jeff Beck, who just came in. Very good timing, Jeff. Any questions you might have about the workshop, they can help answer as well. And of course, we also are very excited to have you all in the room, bringing your insight, your interest, and your expertise to this important workshop. And of course, I do want to provide you some insight into CIRSA. Some of you I know have probably been in several CIRSA workshops before. The Center for Excellence in Regulatory Science and Agriculture was founded with the charge of raising awareness of regulatory challenges, to increase cooperation and collaboration among stakeholders, to address important challenges in an unbiased manner, and to educate the next generation of regulatory sciences. So these are all needs that this unique center provides to the United States and globally as well. And with that, we have a lot on our program, so we need to set the stage. And so I want to bring up Rama Narayaran, and he has been an agriculture chemistry industry specialist for 25 years and has a wide range of expertise in environmental and human exposure and risk assessment. He currently works in the predictive science area, exploring new assessment methods to reduce and replace animal use for pesticide risk assessment, predicting crop residues, and emerging technologies such as precision application and its potential impact on environmental and human risk assessment. So Rama, the floor is yours.
Thank you, Amy. This is the clicker, right? That's good. I think she's driving it from there.
Yeah.
And where did she go? No, not that one, Carrie. Over to your left. Yep, there you go. Good. Good morning, everyone, and welcome to the workshop. Thank you, Amy, for your kind introduction. So incorporating benefits of precision application into risk assessments and risk mitigation of pesticides. So that's what we are here for. So this morning, I'm just going to cover a few things just on the organizational and technical committees that worked, and I just wanted to recognize before we get started, because that's the thing that we'll forget. And then I'll just, just go over what is the scope of this workshop, because if you ask about precision application, it's a very wide area, and we just have 2 days. So what is the scope of this workshop? And of course, it just flows into what is the objectives and the expected outcomes. So when you walk out of here, at least we'd like to have a few things that we have accomplished. And then just about a little bit about who are the stakeholders here and there. And Amy rightly pointed out, CIRSA is a platform that brings in several stakeholders who don't have any other ways to come and collaborate. And this is a great area, and I just wanted to highlight that. And then just go over what is the plan for the rest of the day today and tomorrow. So before we go there, just as a show of hands, who are all on the organizational committee? Thank you. And the technical committee? And give a round of applause to all of these. And what you see here is in the next few days, it took a lot of planning. And then when it is planned, and of course somebody has to execute it, and this is where CIRSA comes in. And Carrie, a round of applause for all the work that you have done, trying to find the place, feed us, and get our badges and everything. She's been working really hard on this. Thank you. And then we also would like to recognize Suzanne, who was the mastermind behind the breakout sessions, which you will come see that later. So what is precision application? So we heard about precision application, precision agriculture, and it's kind of being used interchangeably. What is precision application, precision agriculture? It's been applied in North America for a long time, precision agriculture itself. And we have had it banded applications, variable rate, seed treatments, and even precision agriculture would also be related to fertilization management, water management, and things like that. So it's much more broader. And what we are going to talk about today and deal in this workshop is about precision application, the application part of that. And then we're going to, kind of also focus it down to pesticides. And again, I think when it comes to the point of what is precision application itself, that itself is a wide area. Some of the people in this room are who and who of precision application, who have spent about 30 plus years in this field. And again, I think we are looking at what we are going to look at in this workshop is targeted precision application, more like the optical spot spraying, or you call the commercial products like the CN spray, Green Eye, and things like that, and also the smart guided systems, which is more used in the orchard and vegetable growing areas. And then when it comes to the point of digital and precision agriculture, drones comes into the play. And CIRSA had conducted a workshop some time ago on drones. Drones it gets to the places where we cannot, but for the sake of this workshop, we're going to say drones are not precision applications, so we are not going to talk much about drones. And maybe in a later workshop, we might be able to come and integrate more of an aerial application, a precision application into this, but we are going to talk more about targeted application in this workshop. So again, precision application. Al Womack and colleagues have presented this, made this poster. I'm not going to go into the detail. I believe the poster has been included in your package. And again, I think we'll discuss more about it when we go into the breakout sessions also. But in the meantime, if you have any questions, Al is there in the room. Please check with them on Hepping Zoo, who's going to come right after me. They have spent a good part of their professional career in precision applications, and they can tell you a lot about precision application more than me. Okay, so what is precision application? Let's look at what are the drivers, challenges, and opportunities that we have. The main driver, at least in North America, has been economics. So reduction of pesticides, reduction of application material, and sometimes it's also reduction of a pass, so that the growers don't have to go back. So this has been the main driver so far of the on the precision application. Again, speakers after me, Michelle and others, would also talk about what is the adoption of what are the drivers and things like that. And in terms of opportunities, it's basically reduced environmental, for the purposes of this workshop, is reduced environmental exposure. So reduce pesticide application where they are not needed, or even avoid applications where they are not needed. So thereby you're reducing the waste of pesticides that are applied in places that it doesn't work. And overall reduction of exposure, especially off target, is going to have a major impact on the environmental side of things. And the societal challenges, the society is now looking at more about low residues and no residues in the products that they encounter, but also in non-target and beneficials and other places. So where we think that there is opportunities for precision application. And applicability to endangered species assessment. This is a very complex area, and again, I think we feel that precision application has a role to play to find pragmatic solutions for protecting the endangered species. And some of the challenges or regulatory assessments we have today for pesticides are based on broad acre use or broadcast applications. And the processes and policies that account for benefits of precision application are pretty much unclear right now, because we have not looked into that yet, and which is again one of the things that we hope to kind of like at least scratch the surface and get into in this workshop. And there is of course, when we talk about changing the application, there is uncertainties in the performance. Would the product perform well? As a crop protection industry, it kind of like brings in and say, okay, the application is there, but if the product doesn't work, or if the product has some phytotoxic effects and other things, who would they come after? Who would the growers come after? So that is again, I think this is a challenge that again I think there are some people working on it and looking into it. And of course, it is the precision application technologies are rapidly developing right now. Every day that you have a new technology that is better and bigger. So that's kind of like an overview of kind of the challenges and opportunities. And there are others that I didn't cover. Hopefully that you can bring it up and discuss it later. So moving into the what we saw last week, we saw a memo from EPA about the press release of EPA. What are the commitments that mainly looking at protecting the endangered species, and at the same time that you ensure that the tools and the pesticides are available for the growers that feed and fuel America. So they remain available. So this is again, I think so you can see that's the two sides of the balance. So this is this is a very complex and endeavor that EPA has taken. And they started out in last year. They issued an endangered species assessment work plan, and then along with this, and you have several actions. The high level one would be there is a vulnerable species pilot program called the VSPP, and then there is an herbicide strategy document that was released. And what we hear is soon following that, we'll have insecticides, fungicides, and rodenticides strategy documents. Again, I think these are some of the things that EPA has been working on. We hope to hear a bit more on that. And then, of course, the endangered species assessments has been for the organophosphates and the 4 rodenticides, and there is also a plan for workshops for stakeholders to explore how to offset pesticide impacts on endangered species when there are situations where eliminating or modifying the pesticide usage is not feasible. This is, again, I think this is a very important area, because you have the tools for the growers. If there is no other option, what are the other options that can be done? This is a I would say this is a very pragmatic and forthcoming action that EPA has taken. So EPA has also completed the biological evaluations for atrazine, glyphosate, and they're pending, and they're with the services right now. So this is kind of like what that document that I was talking about, the VSPP and the herbicide strategy, and both of these, what I would show is have references to precision applications, meaning that precision application EPA sees that has a role in some of these strategies that they're for protecting endangered species, and also for the environmental risk assessment as a whole. So this is where I think I would say these documents are very complex and broad, and they do include pragmatic solutions, but the PCA consideration mitigation measures that to reduce application rate and credit is given to the growers to meet the mitigation requirements. And there are discussions and questions related to the implementation of the proposal, how to design the spray program, meet the mitigation requirement, and how to document the reduction. So there are things that kind of like have to be explored, how it is going to work in reality. So this is a step, and I believe that the herbicide strategy, the public comment period is still upcoming, and the stakeholders are working on it. And we believe that the outcomes of this workshop can help with the ongoing ESA mitigation discussions. So let me stop there and kind of like, and we have presentations from EPA and OPMP that we hope that will cover some of these areas. So we've kind of set the stage. What are the drivers, challenges, and what are some of the things we're here for? Coming to the objective of this workshop. So basically, going with the idea of CIRSA, developing regulatory frameworks for what? Facilitate the incorporation of reduced exposure benefits of precision application in regulatory within risk assessments, and to help meet the wider and sometimes conflicting demands and needs of the different stakeholders. And basically, that's why we have different stakeholders in this room, try to kind of sort out, understand each of the challenges and what are the opportunities that they see, and to meet the societal goals for crop protection as well as environmental and human safety. So as a result of this workshop, we hope to have an increased understanding of the current state of precision application technologies and their potential in regulatory implications. So that is the first and foremost, that we hope to have a better understanding when we go out of here tomorrow. And identify the opportunities to incorporate the benefits. How can we do that? Mainly looking at what do we know and what do we don't know and what do we need to know. So that's kind of like what are the opportunities identified, and identify the research models, tools, and other things that will help us to develop a framework for precision application in the pesticide regulatory process. So these are some of the outcomes that we have. There may be others, but these are some of the outcomes that we'd hope that we would get out of this when we are done for the day tomorrow. So now, coming to, I talked about the stakeholders, and around the room, so we have people that are from different stakeholders, And Dr. Arskan from Ohio State, when we were discussing in the technical committee, he basically, unfortunately, he was not able to be here, but he basically said, we never had a workshop or a conference like this. And he was, yeah, and when he said that, it was like, he spent about almost all of his professional career in precision application and other things in particularly from the extension side of things. And when he says that, I think that meant a lot. And so this is basically, it's a unique opportunity to bring in all of the stakeholders in here. And around the room, this is what we have. We have more or less an equal representation from each of these stakeholders that we have, from all the way from regulators, academia, extension, and we have grower representatives to kind of know what is the perspective from the growers firsthand, instead of getting it from a second, third-hand information from reading from somewhere else. And we have regulators from federal government and state government, and we have industry from the pesticide industry as well as the equipment industry. So what is the plan for today? So the first of that, after my talk, we will have the plenary presentations on 3 broad areas on application technology itself, and looking into the grower's perspective, and then into the regulatory perspective of things. So we're going to have presentations from the equipment manufacturers and also from USDA, OPMP, on some of the perspectives on the adoption of precision application from their side. And we're going to have presentations from Dr. Heping Zhu about what is the state of the science and where is the technology is heading. And we're going to hear from Garrett Goins about some of the latest in the precision application technology that's coming. And after that, we're going to hear from the grower's perspective, from a grower themselves, as well as from the extension who are working with the growers. And lastly, from the regulatory perspective, we're honored to have a presentation from EPA, and then we'll finish off with a perspective from the crop protection industry. So that's kind of like the plan for this morning. And then soon after that, we'll have the breakout groups, and we have breakouts on these 5 different areas, and more of that will come after we end the plenary sessions, and we'll be using the 5 bold steps approach to discuss some of these. So with that, I would stop and give it back to the experts who will be talking about that. So thank you so much, and thank you once again for being here.
All right, so we'll bring up our first speaker here, Heping Zhu. So Heping is an agricultural engineer and lead scientist at USDA, ARS, Application Technology Research Unit at Wooster, Ohio, and an adjunct professor at the Ohio State University. He has more than 30 years of experience in development of new methods and equipment for precision application of pesticides. He is a fellow of the American Society of Agricultural and Biological Engineers. So you'll be providing us an overview this morning. Thank you.
Thank you for the introduction. Carry you well. Yeah. Can I also open the video file through presentation. Video file? Yeah, probably it's embedded in the file. Probably, yeah, just, Good morning, everyone. I'm so honored to be here to talk about the state of science for target application of pesticide technology today. There is no doubt that the application of pesticides have ensured abundant and plenty of food supplies. And the application of pesticides will be continuously used for many, many years to maintain this consistency of plenty of food supplies. And, spraying pesticide is the most important, it's the most common method to deliver pesticides to protect crops. There is no alternative that is more efficient than sprayers. Sprayers discharge small droplets to carry pesticides. Different crops require different sprayers, types of sprayers to maximize the performance of or maximum efficiency of pesticide application. Now the question is why we use spray droplets to deliver pesticides. And this is because the insects, disease, weeds, or pests, they all randomly distributed in the field. Not every, in a big field, not every tree get insect disease. Or in the big rock crop field, not every place have the weeds there. So, so because of because of this random distribution of thank you. Thank you. Because of this random distribution of pests in the field, means using the cloud of droplets to carry to carry pesticides is the best way to to have pesticide hit on targets, and also want that spray clouds can be uniformly distributed in the field. So that means if you have the small cloud of droplets, cloud of small droplets with uniformly to cover the entire the field, and then they have high probability to have the pesticide hit all the targets. So that is the reason why we use sprayers, droplets to carry pesticides, and also the concept of the spray is use small droplets to carry pesticides uniformly across the field to maximize probability to hit on targets with limited amount of chemicals. Because we cannot use tons of pesticides to apply, but we use limited amount of chemicals. So for the traditional best management practice is to maximize the probability of pesticides to hit on targets. So they want to optimize sprayer parameters to deliver these pesticides to achieve uniform application. The spray parameters include the sprayer characteristics, travel speeds, droplet size, chemical compatibility, and also crop characteristics, and also many other things, weather conditions, worker skills, so many things. Because of so many parameters are involved for guiding the best management practice, that in many cases, growers cannot follow these guidelines, and they have to, especially when they have to spray pesticides in short, narrow windows, they just apply whatever they have, and what nozzles on the sprayer and what settings on the sprayer originally provided by spray manufacturer. They just use what they have there. So it means all the guidelines got forgotten. So because of this uniform coverage with maximum probability to hit on targets, this kind of practice, they caused tremendous waste of chemicals to long target areas. Means for the area, they have the weeds or not have weeds, or with trees or not with trees, they just apply the same amount, the same area. So it causes tremendous waste to the long target areas. So now, as computer technology is advanced, so the sensor and also machine vision, artificial intelligence system now help sprayers to identify targets and to target spray to target deliver sprays. And these sensors include the optical sensors, the cameras, and also laser sensors, ultrasonic sensors, and they just perform like 100 years ago. The farmers, they use their eyes to identify branches, targets, and then spray them. So now we are back to the 100 years ago's method, means find targets and spray it. But because the spray machine right now is too fast, it's impossible for human eyes to identify these targets. Now, sensor technology is ready to help us achieve this goal. So, for example, the RGB cameras, I mean, with red, green, blue, these cameras with AI machine learning technology. Now to have to identify weeds within canopies. That's on green. So the cameras is just camera. Means like if you say, hey, I see this is the weed, this is plant. But our human brains and eyes have been trained for so many years. And when we see this plant, we immediately know which is plant, which is weed. But for computer, it cannot do that. When you have the images there, you have to train them. They cannot tell this is green, or red, or blue. They have to use millions of images of weeds or plants and train the computer to get a pattern of the specific weed, and then when the camera get that picture, and they will match the pattern already trained in the computer to identify it. So for this spray, each nozzle has a camera, and then when they take pictures, and then they will computer use artificial plant identification technology. Means that millions of images already trained in the computer to find which is the crop, which is weed, and then spray. So if the weed is under the spray nozzle, just one nozzle on, and if weed is between the two nozzles or two nozzles on, so that perform the target application. And also for this one, let's use optical sensors also with fluorescence light. It means that's each the sensor, optical sensor, also release the fluorescence light, and then to detect the green object by fluorescence reflection on the green the target. So this technology can only detect the green width targets on brown or dark field. So that cannot be used to for width in the plant. So that just means if they have the green targets on the detector, means the green target will reflect different fluorescence reflection, so that the sensor can detect that frequency and then identify that this is the width. The others is brown or a dark field. So, and like a lot of sensors also is just use regular cameras and also machine learning technology to create with pressure maps. So this map, they use camera and also artificial intelligent system, plant identification system to detect also detect weeds in the green crops. So that identification AI will tell which is the crop, which is broad leaf, which is grass leaf, and then generate with pressure maps, and then the sprayer will adjust the spray rate automatically based on the pressure the maps. So this is for weed control machines. And Carrie, can you click it on for the video of this one? This is just a embedded video, yeah. Yeah, just hit. Good, thanks, yeah. And also for orchard, nursery, and vineyard crops, their canopy structure varies greatly in the field. And also with the conventional uniform spray practice, I mean, they will spray chemicals everywhere. So now we successfully use that two-dimensional laser scanning sensor, also called LiDAR, to detect the structures of trees, and the size, shape, and foliage density, and then direct each nozzle just spray the trees, canopy, and trunk instead of the empty space between trees. So for big trees, they have more nodes activated, and for small plants, only small nest nozzles will be used to direct sprayers into this into the target instead of spray everything everywhere, because in spread crops, the orchard, vineyard, they have big spacing between trees, empty space between. So that's the big waste of chemicals. And this sensor has 270 radial and 90-degree range, and they can release 43,200 points every second. It's very fast, accurate. So, and with this fast sensor, we can roughly estimate the canopy volume, including the density, and then divide this canopies into sectionals, and then to direct each nozzle to apply the amount of spray as needed. And also we have the variable rate flow nozzle on each nozzle, spray to change the flow rate based on the canopy volume, the canopy volume as needed. Because specialty crops, orchards, vineyards, or nurseries, they have so many different types of crops, and each crop requires different types of sprayers. There is no universal sprayer to handle all these diverse crops. So we designed this system as a retrofit to all existing sprayers. So make this existing sprayer to achieve precision application, target application, without buying new sprayers. So growers like this concept very much. And now this control system has been commercialized since 2019. Many specialty crop growers in USA and other countries are using this system to reduce pesticide waste to the empty space in their production. And also, you can also hit this without sacrificing the efficacy of pest control compared to traditional method. This laser-guided spray system can reduce off-target loss, means reduce airborne spray drift up to 87%, and also reduce the ground loss up to 93%, and also reduce pesticide waste up to 85%. So this is the way they operated previously, and this is the way they, with sensor-guided technology. And also, like especially in nurseries, in a small field, the crop structure changed so big, so the growers don't have time to turn off this nozzle. They have to, their labor cost is more expensive than spraying like this way. So they have to use this way to spray their field. And now with this one, automatically, to change the nozzle, the change amount as needed. So yeah, the precision, the accuracy of this target precision sprayers are not 100%. We all know, but the benefit of economic and environmental issue is obvious. People see how much waste they can save, and also how environmental friendly they have. They can spray near very close residential area, close to some parks, and also public schools area now with this new technology, and without damage or the adjacent crops or also public complaints. But this new technology also encounter so many challenges. For example, the current labor rate is designed for traditional way to spray pesticides uniformly across the entire field, regardless of their trees, or empty space, or the plants. So, and also regardless how many trees or plants in the field, 100 plants or 1,000 plants, or 100 weeds or 1,000 weeds in the acre, they want you to spray the same amount in that area. So this kind of requirement, level rate, restrict the new technology use. So on the other hand, means there are a lot of effective pesticides. They can control insect disease or weeds, but because of their toxicity, now regulations ban them or restrict them for use. Now with this new technology, they can use much less this active ingredient or this restricted pesticide. Now, should we lift these restrictions for these pesticides originally banned or restrict the use? So these are all kind of questions we have to discuss in the future. This new technology is not only good for growers, but also we need some pesticide we don't want to use now, but should we use them in the future because they don't create a huge risks to the environment. Yes. So this concludes my presentation. Now this shows what the spray looks like, and this is what our labs did 40, 50 years ago. They also want to try to create this technology by human hand turn spray on off to see how much waste they can reduce. So we finally achieved the goal that we had many years ago. So I would be very happy to answer any question you may have during this workshop.
Thank you, Dr. Zhu. We'll take questions during the break for our speakers to try and keep us on time. So we next have Adam Barlow, who is going to be talking to us about the latest in spray system technologies and targeted application systems.
That's actually Garrett will be first.
Oh, Garrett. Oh, well, y'all are changing it up on me then. Okay, so.
I'll stand by the mic.
Okay. Okay, well, we'll have Garrett join us first then. So Garrett has been at John Deere for 28 years with the role of project engineering operations, manufacturing engineering, and product safety and compliance. He is chair of the Association of Equipment Managers, Sprayer, and the Sprayer Leadership Group, and a member of the PPDC Labeling Reform Program. Yeah, working group. And last year participated in the PPDC Emerging Technologies Working Group. And so with that, Garrett, the floor is yours.
Thank you. Well, we'll start with product safety engineer. Both Adam and I are product safety engineers. So Hairping, your gentleman on the back of that open sprayer with no PPE just gives me the heebie-jeebies, just like, oh. So that's actually what we're gonna, we have a clicker up here, correct? I think, can you hear me? I'll just stay here. So I'm going to touch on trends in application, and I won't joke. I was going to say we're going to actually now go through the statistical analysis, the equations of what Hairpin said, of how the cameras do the optical identification. I'm kidding. We're not going to do that. So we're going to take more of a 30,000 foot view, and really, why is the technology headed the direction? To give you a little bit of status on the farm. And then Adam's going to cover, okay, we've got this targeted spray technology that Hairpin really did a really nice job of showing us. Okay, now what do we do with it? Can we standardize it? What's it mean, right? Because it's all over the board right now. So let's start with really, and I wanted to back up on my bio. I'm actually a farmer in eastern Iowa. I work at John Deere, but I live on a family farm and operate it, okay, about a 500-acre farm. So this is Garrett's slide. What's the status right now in farming? So my costs this year, all of them went up. I have one cost of all my single input cost, and I mean the entire Excel spreadsheet of my input cost. One went down this year, and that was my nitrogen. So the nitrogen I put on corn, and actually I put a little on soybeans too, that's my only input cost that went down, okay? What that means is farmers are really thirsty for cost reduction, right? So it's a good atmosphere for new technologies to be adopted by farmers, okay? And let's talk safety. There's definitely, I work a lot safer than my father. He's scary on the farm. I don't know how his father lived. As a lot of you know, you go look back in the statistics, the farm was the most dangerous place to work in the United States for decades, right? More deaths, more injuries per person doing it than any occupation, okay? It's definitely improving, and my kids are on me about safety all the time. So that's a good direction, okay, on the farm. and land stewardship. I definitely am more cognizant of what I do to the farm than my father and grandfather, okay? I'm definitely thinking long-term, and my kids even more so, okay? And I think that's true. That's an atmosphere you'll find on a lot of family farms, okay? And again, we're looking at targeted application. And so this is just a tone setter, right? If you can use more chemical, I think that'll definitely be looked at very positively by future generations. So, and finally, the world is getting smaller, much smaller. I can look up on my cell phone. I could probably find who just had a recorded accident on the farm with a chemical spill. I can find all kinds of information, right? If I need a how-to video of how to run a See and Spray machine, I can get on my iPhone and I can find it. A lot different. And that world is shrinking quickly. So why technology? We're going to cover this really quick, but just this gives an overview of where technology is headed and why, at least again from my perspective. We used to manage at the farm level, right? A lot of these technologies and again, I'm representing AEM today, a lot of the colors, all the rainbow of colors of manufacturers are really headed toward plant level management. So with time, we're not there yet, but you'll take your app at the end of the day and you'll not know what you just did to that field. How did I plant it? What chemicals did I put on it? What's my yield map look like? The goal really is you'll know by plant, okay? So long-term thinking, serialized plants, okay? That gives you an idea of the direction. So we're gonna run through these slides really quick. They're gonna be available, okay? What we're really gonna go through here is the tech stack, I'll call it, the building blocks of technology it takes to get to what you've just seen with targeted application, okay? So it starts with GPS. This was a game changer. This was a disrupting technology, basically 20 years ago getting adopted into the farm. Without GPS on the machine, you can't do any of the things we've been seeing. A few, but very few, okay? So this is the building block. Steering. The next thing you saw adopted in sprayers was steering. This gets rid of overlap, right? Farmers used to just drive out in the bean field and drive across it and use maybe a foam marker. The foam markers are obsolete. Steering gets rid of a lot of overlap, okay? So it made the farmer more efficient. Section control, another game-changing technology. So now you can turn off part of the machine, right? There was an evolution here. You used to turn maybe half the machine off, and then you could turn off nozzle by nozzle. And now with those other building blocks, you take it even further. Now we can start to read prescriptions and automatically use the section control. We'll talk PWM signals. So this is pulse wave modulation, okay? Fancy word. What this old valves on the sprayer used to just be on or off. So no flow or maximum flow, right? And the pulse wave modulation has given us basically infinite control of the valve, and there's a valve for every nozzle valve pretty much. It gives you infinite control between fully off and whatever the max rate that can come out of that valve, okay? Again, that's what leads us up to be able to do even greater things. The schematic in the bottom right, the picture in the bottom right, when you turn now with these kind of control systems, you don't underspray on the outside anymore, because the outside of the boom used to go fast, right? When you turn, and you'd under apply. And on the inside, you'd over apply. And now this kind of control system out at the valves can stop that. So again, you're getting, when we see a label and it says 15 gallons an hour, that machine, no matter whether you're going faster or slower or turning, it puts that rate on with a plus or minus, obviously. And again, boom control. So we got a couple technologies here that again, they build on this tech stack. So boom height control. And Hairpin talked a little bit about some of the sensors. So those sensors are also on the boom. So basically you can set it and forget it. I'll call it that. If the boom should be at 30 inches to minimize drift, you set the machine at 30 inches, and no matter how complicated, convoluted your terrain is, that machine is going to follow that contour, and that boom is going to stay at that prescribed height, okay? So to make things like AI work, visual imagery, this is fundamental, right? You've got to start to be able to have this kind of finite control of the machine, this kind of tech, before you can get to the end game that we're talking about for really the next 2 days. So, and then rate control. The PWM signal helps with this a lot. So again, as you turn, go faster or slower, you'll get the same amount, you'll get the prescribed rate that you input in your computer out of the machine, okay? Boundary mapping and spray zones. So again, this technology stack now lets you start to do things like bottom left. You could read a prescription into that sprayer and it'll automatically shut off if you've prescribed that I don't want to spray here. Maybe you've got a sensitive area next to the field or a creek, right? You can see the boundary map. They've set an exterior boundary in the top there in the white line. That sprayer is the boom, that section control combined with the PWM signal valves, it's going to shut off. If the operator hangs the boom out over that exterior boundary, it's going to click off. It's not accidentally going to spray the neighbor's crops too. Okay? Machine-mounted weather stations. So this is an option on a lot of machines, but again, if you're spraying, this gives the operator more control. So if he's spraying a sensitive chemical, maybe they're worried about drift and or it's a volatile chemical, so now he knows the temperature, right, on board. And LiDAR, this got touched on in the prior presentation, but again, this is a technology that's been around a long time, but now being adopted into sprayers, and it makes it uses lasers and it makes a three-dimensional map of your environment. What that lets you start to do is identify crop. So it was being used in that video. That's how that machine using LiDAR, that's how it knew if there was a tree there or not a tree, and it allowed it to kick on and off, okay? And then this can also be used for guidance. This is a big stepping stone for guidance. So you see some autonomous vehicles, and that machine in the top, that's how it knows how to drive through its environment. It's using an onboard LiDAR to map and make a map, and then it can guide itself between the trees. And then finally, that whole tech stack on top of one another, you get to targeted spray, which is our topic, right? And I've already covered, there's lots of different, I want to give credit though. I want to make sure as an AEM member here today. So you've got John Deere See and Spray has been covered. You've got Green Eye, you've got Weed It, you've got Trimble has Bilberry, their Smart Spray through Bosch, Smart Apply, and Weed Seeker, okay? So we've talked a lot about See and Spray, and people have been using the word See and Spray, but all these different manufacturers have machines in the market and are all part of the targeted spray technology, okay? We've already really talked about green on green, so this is an example. You've got a cash crop out there, and you can see they put blue dye in the machine, so you can see where it's sprayed, some of the benefits, and various manufacturers make different claims, and one has made up to 90%, right? And I get asked a lot of questions about, well, how do you know how much you're going to save? And it's purely a weed density, right? It's simple math. So if a targeted spray machine goes out, let's not even use this kind of application. Let's go out to the orchard. And if the orchard has trees everywhere and they're all tall, it's going to have to spray a lot, right? But if you've got targeted spray and you've got gaps, it's going to turn off. So how many gaps do you have, right? Or how many variations in tall crop versus short crop? So there's really no answer. There's no question or there's no exact answer to that question, how much it's going to spray, okay? That leads up to Adam to talk about standardization, because we've seen lots of variations of targeted spray technology and what it is, right? So Adam's been leading a group that he's going to talk about that's working to standardize it.
Yes, hello. So my name is Adam Barlow. I also work with John Deere. A lot of my role is around the standardization of new technologies and creating test standards and performance standards. So today I want to talk a little bit about what we're trying to do with targeted application and some of these new systems that Garrett and Herping mentioned this morning, and creating these standardized tests that you can go out into a field or in a lab environment and conduct and give you some data and some feedback. And I'll show you a little bit what that's trying to look like here. So the process really, here in the US, our national standards body is ASABE. To start the process and standardization, we actually go to the ASAB leadership and ask for a project approval, which we have done that so far as we are here today. And then we have a call of experts, that's kind of where we're at in the process right now, is trying to gather folks not only from industry, but the chemical companies, but also policy and regulators as well, to join us in creating a test standard that can be used and meet goals of not only industry, but also the chemical industry and policy as well. So the big thing to note tier 2 with a national standard is that it can be directly adopted into law or policy here in the U.S. So that's why we are trying to move forward with a national project this time and not international. The next step here would be establishing a working group. So that's kind of the next step in this process. I'm hoping to hold our first working group meeting sometime next month to kind of go through the standard that we have today and kind of showcase it and see what folks have to say about it. And then it's creating testing and acceptance criterias around so after we develop the testing protocols, it's like, okay, well, how do we make sure we are aligned on what the outcomes are and data that we want to collect. Next step would be hopefully next spring, if we can get to that point, would be actually validating with this testing. And so we'd like to use some USDA research facilities where Herping is and Hongyang to kind of validate that the tests that we have in the standard make sense and that they're going to work for different industries. And then a standard test proposal. We actually make a proposal. It goes then into the ASAB sprayer overall committee for a vote. And then if they vote to approve, we have a published standard, like I said, that can be adopted directly into U.S. law. So project timeline, as of today, we are still working on establishing a working group. And one reason why I'm here today too is to continue off of that, but conducting outreach for engagement. So folks that have interest in engaging with us on the standard, you can actually sign up through the ASAB organization. A lot of folks will probably just want to be on as observing, as you're able to see the progress of the standard as it moves forward, ask questions. You can even make comments too, you just can't vote. If you do want to be a voting member, that is a possibility as well. 8 months out, like I said, next spring, once we have some crop back in the ground, early spring, or actually early summer, we'll do some field trials. So I'm hoping to get a lot of different manufacturers engaged. We can actually do some field trials out in the field, performing these tests and actually collecting data and showing what these products can do. And then hopefully, I have a note there too, this represents the fastest process, but if everything goes to plan, early 2025, we can actually have a standard published that can be used across industry in the US and Canada. So why is standardizing performance needed? So really these are the core bullet points here, but measuring detection accuracy and the amount applied, obviously that's number one. Seeing how these technologies, they have different accuracy levels and different performance, but then you can actually categorize different types of these technologies as well. So kind of what we're thinking is we'd have a categorization of a 1 through a 5, right? A 5 being the most accurate, or 1 being the least, but they all have their advantages with customers. Some folks don't need the super accurate technology; they're more based on speed, right? So that's how we'd categorize that. But it also provides data to the EPA and plant protection product manufacturers as well for any updates maybe to potential labeling. So like Herping mentioned earlier this morning, right, a lot of the chemical labels today are all set for a conventional sprayer, conventional broadcast sprayer. This is something totally different, right? That's not going to be on a label. So this data that we can get from this test would be able to allow, that's the next bullet point here, but allows the environment to achieve environmental goals, but updating those EPA risk assessments. Knowing if we're applying X amount less based on a certain weed pressure or weed density, that can kind of change the way these risk assessments could be done. And then I did already mention that, but yes, a national standard can be adopted directly into U.S. regulatory policy. So that's very high level of what we're doing. I'll be around obviously the next 2 days if you have questions around this standard that we're working on. But again, we're looking for more engagement. Like I said, a more well-rounded group really helps develop a great standard, right? So we're not having to go back in and revise it constantly. We can have something in place, hopefully within a year, that can get the data that folks need and start moving forward in this new direction. So with that, is there any questions? I guess we're going to take questions later. Okay, so thank you.
Thank you, Garrett and Adam. Next, we'll be having Michelle Randall, who will be giving us a grower's perspective on precision application. So Michelle is a senior agricultural economist in the Office of Pest Management Policy of the U.S. Environmental Protection Agency, Office of... Okay. So she's been with the program since 2015? Yep, okay. Yeah. She's also worked at cost-benefit analysis for regulations and laid an effort to develop a method for establishing economic minor uses of pesticides. And so with that, welcome, Michelle.
Thank you. Mm-hmm. Yeah, hi everyone, Michelle Ranville, and I think, yeah, so I can actually, okay,
We want to make sure
sure that works.
they can hear you.
And do I press this one? Okay.
Yeah.
Okay, thanks.
Thank you.
So I previously worked at EPA's Office of Pesticides, and I currently work at USDA, Office of Pest Management Policy. And just a brief overview of what I'm going to cover today. First of all, I am going to introduce USDA's Office of Pest Management Policy. I think most everyone knows who we are, but I do want to kind of go over what our role is in pesticide policy and how and why we were established. And then I'm going to go over a couple of points about precision agriculture or application. First of all, some of the benefits of adoption. We've just heard a whole bunch from Dr. Zhu and Garrett and Adam about these technologies. A lot more than I'm going to cover, and that's great. And I want to talk just a little bit about the benefits of adoption of those technologies from the grower's perspective. And then I'm going to go over some adoption rates, although we don't really have very great data on adoption rates, at least from USDA. We do have some data on adoption rates for precision ag, though, and I think that can help us to frame how we look at this overall. And finally, I want to go over some of the barriers or challenges to adoption, and Todd is going to go over that a lot more later in his discussion, but I'm just going to touch on a couple of points that I think are important. And then finally, some issues and questions to consider today and tomorrow and as we go forward. Okay, so to start off, USDA's Office of Pest Management Policy, OPMP. We're a small office located in the Office of the Chief Economist at USDA. We're just across the mall over here. And we take the lead at USDA on pesticide regulation and policy issues, integrated pest management, and agricultural biotechnology, especially as it relates to pest management. So we regularly coordinate with EPA, FDA, and other federal and state entities on policies that affect pest management in agriculture. And we do that mainly by collecting information from our stakeholders. We're continuously consulting with grower groups, pesticide registrants, applicators, distributors, retailers, and as well as, of course, cooperative extension agents and other scientists in the field. With respect to data, information, and collection on pest management practices, we are also authorized by the 2018 Farm Bill to conduct a survey that we have done a few times now. We can conduct a survey with crop advisors, so it kind of gives us a broader reach on issues that we might want more than just a one-on-one discussion. And we've used that to collect information on atrazine usage and benefits, malathion usage and benefits. Most recently, we did a survey on rodenticide use in outdoor ag production. And right now, we're doing a survey, or just conducted a survey on grower use of runoff management plans, federal and state. So that's something that's related to ESA, but we can talk more about that later. OPMP was established in 1998 by the Agricultural Research and Improvement Act, and we were established in response to the Food Quality Protection Act of 1996, which set the dietary safety factor for food on pesticides. And when FQPA was passed, it required a lot of new risk assessments to be developed, and we wanted to refine those risk assessments through incorporation of usage and monitoring data and assumptions about agronomic practices. And by the way, if you're doing the math in your head, our 25-year anniversary is coming up this November, actually. So we are probably going to have a party, so stay tuned. So actually, we find ourselves in a very similar situation today with regard to ESA policy. We need to collect information about usage, agronomic practices, the importance of different chemical pesticides, and how growers are handling pest management in different areas. So our work now feels as relevant as ever. But again, our core work is mainly to represent the perspectives of growers to EPA and to help inform pesticide policy in the US. We routinely comment and coordinate on things like proposed interim decisions from EPA through reg review, or even new active ingredients, interagency rulemaking consultation, and that sort of thing. Our office is pretty small. We only have 10 people, but we do have a broad range of expertise and experience. And 7 of our staff have actually formerly worked at EPA's Office of Pesticides, including myself and our director, Kimberly Neshy, who's here today, and our human health risk assessor, Julie Van Elstein, who's also here with us today. Okay, so I want to start off with this very long definition of precision agriculture. This comes from the International Society of Precision Ag, and this was an attempt to pull together a whole bunch of different definitions in 2019 and kind of synthesize those. Precision agriculture is a management strategy that gathers, processes, and analyzes temporal, spatial, and individual data and combines it with other information to support management decisions according to estimated variability for improved resource use efficiency, productivity, quality, profitability, and sustainability of agricultural production. That's really a mouthful. I think you can more easily just say it's producing more with less. And why would growers want to produce more with less? Well, I don't think that it's news to this group that growers are squeezed in a number of ways. Growers are constantly trying to reduce their resource usage for some of the reasons that Garrett just mentioned. Costs are going up. First, land cost and availability. You hear growers always saying that new growers can't find land. Land value has increased by 30% since 2020. I just was talking to Mike Ertz a couple of weeks ago about Florida vegetable production going down, and he said, well, there's 1,000 people moving to the state every single day. So land has competing uses. Rising input costs. This is huge lately. Growers have faced rising input costs in a number of ways. The cost of chemical pesticides in particular has increased by 50% since 2020, and that was not even the high point. A lot of that was herbicides, but chemical insecticides and fungicides have also seen an increase of about 15 to 20% sustained. The price of fertilizer went up about 100% over that time period, so even worse. Labor costs and availability, the same story. Wages are consistently rising, and there are shortages. And then policy restrictions on inputs. So pretty much, if you can think about an input into agriculture, it is probably regulated in some way, and how you use it, how much you use, where you use it, when you use it. I just got back from a trip to California where we heard about nothing but their water usage, right? So many issues out there with respect to how much water they can use, where they can use it, who has rights, and all of these things. So another thing, import competition, or I really should probably just say competition in general, because most growers are price takers in the market, okay? They grow commodities, so growers don't get to set their own prices. So really, reducing their costs is the only control that they have over their profitability. With imports coming in, or just an increase in supply from even a good year domestically, price is going to go down across the board for commodities. You see small attempts at growers trying to brand their products. You can all think of like cuties or things like that. But for the most part, these are commodities, so they take price. Okay, buyer demands. And by buyer demands, I don't really mean us, the consumer. I kind of more referring to retailers and wholesale buyers of ag products. And growers, especially growers of food, face things like food safety audits from all of their buyers that are privately implemented. These do not happen, or not a matter of regulation necessarily. Most recently, I saw a case with potato growers in the Northwest where the wholesale potato buyers in the U.S. are, some of them anyways, are pushing a regenerative ag strategy on growers that is actually going to require them to reduce pesticide usage on the farm to meet the standards, by 2029 or 2030, I think it is. Climate change, of course, is going to put additional pressure on growers, reduced yields, an increased price of inputs, and then, as Garrett mentioned too, environmental stewardship. So growers want to preserve their land, they want to reduce the inputs, they want it to be there for future generations. So there are a lot of reasons why growers would want to reduce their inputs, but unfortunately, there are not usually a lot of good solutions for how to do that, except for in the case we're talking about here today. There are actually some good solutions in forms of technology and practices that growers can use to reduce pesticide inputs. And so I'm just going to cover a couple of those really briefly, and we've already seen the more in-depth description of these just now, but Intelligent spraying in orchards, and I'm really referring to, Smart Apply is the commercial name. I've seen estimates that they can reduce chemical savings by 20 to 90%. So this is for, spraying, you spray fungicides into the canopy, insecticides, plant growth regulators. So as we just saw, this technology is going to prevent spray from going over the canopy, under the canopy, and sometimes even in these little, you can see in the shadow here, there's little tiny spots. Those don't need to get sprayed. So the chemical savings of 20 to 90%, well, is that a lot? So I was looking at some budgets for orchards, and typically speaking, chemicals sprayed into the canopy can be 20% of the infield variable cost in an orchard. So yes, even saving 20% of 20% is 4%. You don't have to get out your calculators. So even saving that much can be a significant cost savings for growers. How fast a grower can recoup their investment really depends on the size, and maybe that's something that we're going to discuss here. I didn't want to put any prices up here because I think we can discuss, field size and things like that, and how long it can take a grower to recoup their investment. But depending on your size, 3 to 4 years, maybe even 1 to 2 years, you can recoup an investment in an intelligent spraying or a Smart Apply system. Some of the potential disadvantages: maybe not effective against all orchard pests. So if you think of something like red scale that's tightly adhered to the fruit, of course you just want to spray the fruit. But if you're thinking about something that's flying around the orchard, I'm hearing that maybe we actually want to spray beyond the trees. So maybe it's not effective in all applications, but still many. And then requiring time and cost to learn and calibrate. So these are not something that you just walk out there and use it the first day. You do have to have practice, so growers do need to learn. There's a learning curve to any of these things. Okay, targeted spray in row crops, or See and Spray as it's branded by John Deere. This is a picture of a spray rig that we saw in a potato grower in Northwest Washington. And as we just saw, you can kind of see the little camera up there at the top, and those are mounted along this spray rig. And the cameras are identifying the weeds and spraying only the weeds. In a pre-emergent application, it's pretty clear. They just spray the green. So herbicide savings from targeted spray can be up to 80% or so. We actually did see this with the potato grower. They showed us their data output. Of course, they're in a very dry area, but they showed us the comparison. They were saving around like 78% from using the See and Spray system versus just the broadcast application. They're in a dry area, so not much is growing without irrigation there, but still, this is possible. And again, asking the question, does this matter, this 80%? It does. Herbicides can account for more than 10% of variable costs for some row crops, so saving 80% of even that small amount can really matter. Again, this is really dependent on size. A large grower can recoup investment in 2 years. We can talk more about that later. Some potential disadvantages: it is a pretty high investment cost for these systems, so probably not something that a small grower is going to adopt. And maybe less effective in areas with elevation change. I know the technology is changing all the time, but where there's a really hilly area, it may not be as effective as a flatter area. Okay, so you think, well, great, we have these great benefits, we can save a lot of money, so everybody must be adopting it. Well, truthfully, we don't really know how many people are adopting it, but we do know a little bit about precision ag adoption in general. This report was published earlier this year at the Economic Research Service, and it uses data from the Agricultural Resource Management Survey, or the ARMS. The ARMS survey focuses on 1 to 2 crops per year. It covers corn, rice, sorghum, winter wheat, soy, and one other one I'm missing. But no other specialty crops, no orchards or anything like that. So 1 crop a year typically, and the advantage is that they do a really detailed look at practices and collect exactly what a grower is doing, how they're applying their pesticides and when, and they ask about these things that you see listed here: the use of yield maps, soil maps, yield monitors, variable rate technology, guidance systems, and aerial or satellite imagery. And for variable rate, or VRT, they're looking at seed, fertilizer, and pesticides. So main findings of this report, as we could all expect, adoption of precision ag is increasing, but it's still low for some tools. Specifically, soil maps have kind of even gone down a little bit. Guidance systems, or auto steer, is the most commonly adopted technology, more than 50% across all planted crops in these 6 row crops. But VRT for pesticides is relatively low, 7 to 10% of planted acres. And that is despite the fact that growers can actually receive a $10 to $12 payment per acre through Conservation Stewardship Program for using this technology. Another important finding from this report is the large versus small. Okay, so at least half of large farms are using yield maps, soil maps, VRTs, and/or guidance systems or some combination, but under 15% of small farms are using these, except for cotton is a little higher. By large farms, I mean farms in the 4th or 5th quintile, small farms smaller than the 1st quintile. Okay. We have one other source of data that can tell us a little bit about precision agriculture adoption. And this is adoption across all farming operations. So it's called the Technology Use Survey now, but it used to be called Farm Computer Usage and Ownership. And in the year 2021 and 2023, they asked the question, in the last 12 months, did this farm or ranch use precision agriculture practices to manage crops or livestock? And it gives some of the examples that we just went over, including a couple that apply only to livestock operations. So in 2021, 25% responded yes. In 2023, only 27% responded yes. Farmers were going through a lot during this time, so it makes sense that they would not be out there trying to adopt a whole bunch of new technologies. Cost increases have been a struggle. But what I think is most interesting about the data from this report is the difference in adoption rates by state. Okay, so very low adoption in West Virginia, Kentucky, Virginia, Florida, Georgia, and Texas. And this is anything, so this really covers any sort of precision ag. And then high adoption in the bigger, states, grain-growing states, okay, all the way up to 57% in North Dakota in 2023. Okay, so we unfortunately don't have very much data at all on specialty crop adoption. USDA did ask a couple of questions in their 2019 fruit and 2020 vegetable chem use surveys. They asked about the use of infrared sensor-based technology, variable rate, and pulse width modulation only in 2019 fruit. We don't have this data. It was never published. We're trying to get a hold of it now. And it has to go through a disclosure process at NASS because it was not published, which takes a lot longer than we thought. So anyways, we don't know, but the data, we've seen the data, and it's a little bit sparse. There wasn't a lot of response rate to it, so it may not be much. But there was actually a 2018 survey of specialty crop growers in Florida through the University of Florida that found that 20% had adopted some form of precision ag. And again, we're talking about everything from use of GPS on the farm to sensor-based technologies, variable rate, that covers everything. So only 20%. And this would be vegetable growers and orchard, 20%. Okay. So these technologies are so great. What are some of the barriers to adoption? Why don't we see that everybody is just out there adopting all of these things? Well, there are a number of challenges. First of all, farm size. Smaller farms are less likely to adopt, and that's just a numbers game. They cost money, these technologies sometimes. Investments don't make sense on smaller farms at times. And they can be a very high capital investment or an unclear return on investment. And this is something that I heard from a vegetable grower in California this past week. Yeah, our neighbor's a little bigger. We're going to wait to see what they do first, and maybe we'll buy their old equipment, or maybe we'll see how it works out for them. Farmer characteristics play a role, so age tends to have a negative effect on precision, or age is negatively correlated with precision ag adoption. Education and computer literacy are both positively correlated. Access to high-speed internet is still somewhat of an issue. While 85%, and this comes from that report that I just put up, the computer use and farm ownership, 85% have access to internet overall on the farm, but only 75% have access to high speed, so that's broadband or satellite. So that still leaves 25% of people, and we actually heard this from a grower in California who had tried to adopt a drone that was going to do scouting. And first of all, they were on a hill, so the drone didn't work right. The pictures were all messed up. But then they only had, this farmer literally had 40 gigabytes of data. They were on a cellular plan, so they had to take the pictures somewhere and upload them and get them to this was really, it was impossible for this person to use this technology until they recently got satellite. So The process equipment too complex for labor. I just ask people to think about the last time that you got a new piece of technology and how long it took you to use it and how much you seek out these opportunities in your work. I got a new camera recently. I switched brands from Nikon to Canon. I'm a photographer, and it took me forever. It was really hard for me to learn the menus, to go through, and I'm never going to learn how to use this, and things were always messed up. And it is the same thing for people on the farm. Every time they bring a new piece of technology into their system, somebody has to learn how to use it, and that takes time. And finally, and I really want to kind of highlight this because this came up a lot in the past week. I've been in California for the past week on the California Ag Leadership Foundation's DC Exchange, and it was a really great experience, and I used that opportunity to ask a lot of questions about the adoption of precision ag. Why are you doing it? Why are you not doing it? Negative past experience came up a lot. People said things like, yeah, we tried that. It didn't really work. It took it was a waste of money, waste of time, this sort of thing. And once something like that has happened, these people are going to be that much more reluctant to try something again. They've seen these systems before. They didn't quite work right. We heard specifically about a sensor system. I don't think it was smart apply, but where the sensors weren't turning on at the right time in the orchard, and it was missing like a quarter of the tree going into the next tree. So that's not acceptable. When you're spraying a fungicide, you have to get full coverage. So this just wasn't working, and then they get exhausted, and of course they're dealing with their water issues and everything else, so they don't have time to go back to it. So a negative past experience is a really big deal. Okay, so finally, just some issues and questions to consider over the next few days. We're going to go into these things a lot more, but are we trying to get these technologies incorporated into risk assessments, or are we aiming for incorporation as an ESA conservation or mitigation practice? Both could be beneficial to growers. We're in a situation right now where, for example, existing orchards have almost no options they can pick off the ESA mitigation menu that will work for them. So something like this that could be an option for them to choose could be really helpful. And is that path the same going forward? Do we need the same data? Do we need the same process? Could one be done before the other? Maybe an ESA mitigation practice in the meantime while waiting to think about incorporating into risk assessments. And hopefully we consider how can specialty crop growers and smaller farms benefit. The majority of our food and ag is conducted on large farms. The big farms grow the largest percent of our food, but more farms are small. So it would be great if everyone could benefit from these technologies, and how can we do that? So also, can the method or strategy developed from this workshop be repeated for other technologies and practices that reduce usage and/or exposure? And I know that we're focusing on these sensor-based technologies here, but there are a lot of things out there that can reduce exposure, ecological or even occupational exposure, hooded sprayers, banded application, VRT, reservoir tillage, autonomous sprayers, the Gus that go, we just saw a picture of it, that is automatically driving around the orchards. No contact mixers, drone applicators, and more. And there will be new technologies in the future. So a process versus a case-by-case approach would be most efficient if it's possible, but maybe it can't. And so maybe that's not possible for the EPA pesticide system, but we're going to hear more about that, hopefully. Finally, I just want to point out, and Adam talked about the standard setting, representation of equipment users, growers, and applicators is needed, and it's critical wherever decisions are being made. So for example, the standards committees. And I think it's critical not only to make sure that they're represented, but also so that they pick it up, so that they want to use it later, and so that these solutions work for them. And as Adam just said, a better standard, more representation of groups is going to make a better standard. Growers are worried about different things than manufacturers are. Where they're worried about usability, I would imagine they're worried about the right to repair their own equipment, and also worried about the ownership and security of their data, as we all are with use of new technology. And so that's all I have.
Hey, thank you, Michelle. Our next speaker is Amy Fulcher. Is she here? She's coming up. Okay. So Amy is a professor and extension specialist at University of Tennessee, where she specializes in irrigation and pesticide application. She's part of a multidisciplinary team that's developed laser-guided variable spray rate technology and is evaluating its performance in nurseries and orchards. And so with that, we welcome Amy and look forward to your talk. Do you want this?
I'll take this. Can you hear me okay? All right. I've spent most of my career working with nursery producers, and over the last 7 years have also started working with orchardists in collaboration with Dr. Dave Lockwood at the University of Tennessee. And what I have experienced working with growers is they tend to use an air-assisted sprayer. We would call them air blast sprayers, and Dr. Zhu showed you a lot of great examples of these sprayers, and also the kind of double-edged sword of an air blast sprayer. So that spray cloud that billows and will kind of envelop the leaves on several rows of trees within a block is also the spray cloud that will drift and has the potential to put spray droplets where we don't want them. And as he pointed out, a fairly low pesticide application efficiency. Another point I wanted to make kind of as just background information is that most of the labels that I read when I'm helping a grower are instructing the product to be applied at 100 gallons per acre, the mixed spray solution. So I have growers that spray at 100 gallons per acre. I have growers who intentionally calibrate their sprayers to 50 gallons per acre, some even lower than that. I've also worked with growers that through the course of us calibrating their sprayer, they learned they were actually applying 150 gallons per acre, and they didn't want to do that. That's wasted money, among other things. So just a little bit of background on nursery production. And do you mind to play? Both of these are videos. So we've seen some videos and pictures, but I wanted to show you these because I'm going to also show you data from this orchard. So on the left, well, this is the same sprayer. Let me say that this is the same sprayer in variable rate mode on the left, and then operating in its normal constant rate mode on the right. And it's such a dramatic difference. I mean, to me, just seeing that is really powerful to get the sense of how much less spray is being applied using the technology. And let me back up a little bit. So I was trying to edit my slides a little bit, thinking about who was speaking before me, but I've worked with Dr. Zhu for many, many years now, a privilege of mine. And we helped him test the original variable rate intelligent sprayer prototype and then the retrofit. And the videos I just showed are from the retrofit. And of course, that then became the partnership with Smart Guided, Smart Applied, and then ultimately John Deere. So these are some of the tests and partners that I've done those tests with in Tennessee over the last 10 years or so. And just like a common theme, reduce spray volume and also drift. And I'm going to focus on that a little bit. We found again and again, I mean, the more a grower sprays, the more they save. The more there's a disparity in tree size, which is so inherent to nurseries. I mean, there are hundreds of different species at all different stages of growth. And of course, at orchards where you have replant and really large 20-foot by 20-foot trees next to brand new ones, replacing dead ones, we see a lot of savings from those scenarios, like really the highest savings, the more disparity there is. We have not seen any decrease in arthropod or disease control. So I want to emphasize that. We have tested it with mites, with insects, with fungal diseases, and we have never found any compromise in control over 10 years of testing. I want to highlight a few of the projects and results that we've had with our partners in the industry. This is Mark and Chubby and their wives and their mother-in-law, and they run Orrin Wooten's Apple House. And the videos I just showed are from their orchard. And at Wooten's, we worked with a couple of different groups of trees, some really big 20 by 20 Golden Delicious trees, really bigger trees than you typically see in an apple orchard nowadays. You know, they're more trellis grown and dwarfing rootstock. We also worked with these Rome apple trees that were much smaller and looked at the savings that we were getting from the laser detecting the trees becoming thicker over the course of leafing out and growing during the season. And even with these large trees, we saw a 37% reduction just from differences in the gaps at the top. It otherwise was a closed canopy. We saw up to a 74% reduction in pesticide volume sprayed from the smaller trees. Like I was saying, the more space between the trees, the more disparity in sizes, the more savings. But what was really interesting to me was the reduction in drift. We weren't changing anything about the fan speed, the power, but we still had a 40% reduction in drift. That was, as a non-engineer, that was very interesting to me. Some of you are probably like, well, of course, but I'm a lowly horticulturalist. Okay, so one of our other partners here is at the Apple Barn. Have you been to Gatlinburg, to the Smoky Mountains, any of you? So you went through Sevierville and then Pigeon Forge to get there. And then you went right by the Apple Barn. This is the Comfort Inn. Walgreens is right here. Orvis is right here. And the Titanic and the Upside Down House, you know what I'm talking about, 2 blocks that way. I mean, we're literally 1 block off of a 6-lane highway. The more traffic coming through that part of Tennessee than anywhere else. It's 15 million visitors, 15 million cars. They're looking at creating a new exit now. But they're all going within 1 block of this business. So one of the projects we did with them that Dr. Zhu made possible was installing the retrofit technology on their existing sprayer, and then they sprayed half of a field in variable rate and half in the intelligent rate. We couldn't have done it without them. We couldn't have been there every so many weeks as often as they sprayed, but we did go every 2 weeks, every week, and we monitored the foliar diseases, insects, and then later we started monitoring weekly for fruit diseases. We saw 58% reduction in spray volume, and that was after we had already helped them refine things and reduce their spray volume a little bit just by closing some of their upper nozzles. Based on the height of their trees, they did not need those nozzles. But what was so really rewarding and powerful to me was a 95% reduction in drift. That was huge. You can see, I mean, cars are just driving right by us. Sometimes they would stop and watch, but there's so much traffic right there. Buses of people going to the Apple Barn within 20 feet of this field. One other partnership that I want to mention is with Hale & Heinz Nursery in McMinnville. They have been partners of ours for many years now and have made so much possible. We installed the retrofit, the universal technology on their existing Tafoni Storm 2000 sprayer. They had a pair of these. And so James got to drive the one with the technology. Reuben got the one that didn't have it. Reuben had to fill up almost twice as frequently as James as they would go through the nursery. They sprayed at that time on a every 3-week rotation. Because of an emerging disease in our industry, they now spray every 2 weeks, trying to prevent that from getting a foothold, getting in their nursery, and then getting established. This is a unique site in that they're pot-in-pot production. So they have these permanent, semi-permanently installed socket pots in the ground, and then the trees are growing in production pots of the same size that just nest down in those during the time of production. And their blocks are 6 rows deep. And then they have a narrow driveway and another block of 6 rows. And I thought, when is the laser not going to see something that needs sprayed? I really was not sure what to expect. In this configuration, we still saw a 24% reduction in volume and a 74% reduction in drift. So again, I'm just really, really encouraged by the potential that the reduction in drift was bringing to this ecological system. I mentioned that Reuben had to fill up about twice as fast as we got. This is their smallest size of pot and pot. As we got into bigger trees, there's more space between trees, fewer rows to a block. So an overall, when we measured, it was 43% reduction. And I'm going to skip this one in the interest of time here. All of these results, the drift in particular, kind of helped foster an interest in how can we look at the impact, if any, on beneficial insects that are in these nurseries and orchards. And so with the partnership of these growers, we asked them to spray in their normal constant rate mode in half of the field, variable rate in the other half. And then as part of our protocol to measure the control of the insects and diseases and fungi we were spraying for, we developed some quick assessments of pollinator populations and natural enemy populations. So this is a little more complete view of the pot and pot nursery that we saw a few slides ago. And notice that it's pretty much bare ground at this size of nursery. We made 48 nursery floor and 168 canopy observations for each species in each treatment. And on this slide and the others that immediately follow, we've got the number of insects on the y-axis, a pair, the bars are a pair with the variable rate on the left, constant rate on the right, and then we've got the 2 tree species. But at the end of the day, all you need to know is there weren't very many. There was really, really not very many. So that was eye-opening. That was really valuable to see. This, to me, this was just our initial foray into looking at the levels of these beneficial insects. And I should say we did this in partnership with Dr. Laura Russo, who is a wild pollinator entomologist at UT. Now, same slide set up, but for natural enemies, we did see a little bit more. Still not blown away by the numbers, but again, we don't really have a frame of reference either. We're not scouting large areas. We're scouting a section of a branch that we are also using to monitor control of a particular pest. The lacewing eggs are often the biggest bar here and here, the dark and light gray. And I think that's partly because they don't move, they're stuck, and they're very recognizable. They look like a Q-tip stuck onto a leaf or onto a stem. So that may have as much to do with anything as to why we saw so many of those. Moving on to a field nursery that we partnered with, you can already see a big difference in the floral provisions that are present and just the habitat that are available. 50 nursery floor observations, 150 canopy observations for each treatment. This nursery sprayed approximately monthly. And again, pollinators, natural enemies, not really huge numbers, but again, we're still learning what should we expect here. There's not really a body of literature for nurseries on this topic. And again, the most static, the egg, and easily recognizable is the majority of what we're seeing here. And then one final piece from this series of experiments. We did this a little bit differently at the orchard. We created a 1 square meter quadrant. We placed it multiple locations and driveways adjacent to rows in the variable rate block, and then the block that was treated with constant rate, and monitored for a total of 135 minutes, and pollinators only, looking for them to visit the flowers. And here There's a lot more data and literature that we could go back and compare this to for orchards. But here we're seeing 29 and 30 more than we'd seen at any of the nurseries for sure, and with that declining over time, and a much bigger range of the types of pollinators that we were seeing compared to nurseries. So just some early impressions. This I really consider just learning what we might find, what is out there. There are lots of things we can improve on. We don't have a real good frame of reference. The numbers seem to be low to me, and that's partly a function of the habitat that's inherent to some nurseries. Also, the spray history. You know, if a nursery has sprayed every 3 weeks for a decade, maybe it's going to take a little while before those populations come back. Also, you know, one of the real challenges with our experiment is that our little oasis of variable rate treatment was surrounded in some cases by constant rate. And our insects would need to come and go through that area. They're mobile. They're flying, most of them. So we can't really separate out our treatment in this kind of situation. So we thought about other things that we've done when looking at the impacts of systemics versus contact insecticides. We've used pitfall traps, and we started considering other monitoring methods. And I don't know if Carrie is back there. If you can play this video and maybe mute, I don't know if you can see this, but one of the things at this same time then is my program started looking more at can we use these sprayers and this technology to focus on the trunks of pests to get at scale, to protect against trunk-boring insects. And so we've devised an experiment to kind of do both things, and I'm going to focus on the effect on beneficial insects. This is a more controlled study. We call it a no-choice study because the insect doesn't have a choice. They're going to be trapped with something that was sprayed, something that was treated for a prescribed period of time. So it's considered a worst-case scenario type of test. You can see this is our plot here. We had 2 rows of red maples, and you can see there's a driveway down the middle and on each side. The green circles are the trees. The tan rectangular shapes are boards that we would outfit with targets. And we'll look at those more closely in just a minute. For this, we tested the variable rate where every nozzle had the potential to be activated, and in fact, we had it set so that they generally would, compared with the constant rate, all of the nozzles operating, constant rate just the lower nozzles, because again, now we're really focusing in on trunk pests. And so here's a look at those boards. Here's a mesh disc that we used as a target. We used an ultraviolet tracer along with the insecticide in the spray tank. And we used a lot of water-sensitive paper. Not going to get into that today. And then here you see the leaf. So these leaves were either on boards within the block or at the base of drift structures outside of the block, like we saw in the previous slide. And so after we would spray in one of those 3 different modes, we would collect the leaves. We had already run them through a leaf area meter, so we could adjust and estimate the amount of spray that was on that leaf. We would place each leaf in its own petri dish with 10 lady beetles, and then we'd monitor them for 4 days, daily for 4 days. And so on these and the subsequent slides, insect mortality or percent normal behavior is on the y-axis. And then we've got the leaves that were within the row, within the block on the left-hand series, and the leaves that were in the drift location outside the block on the right-hand side. And then orange represents the constant rate. All nozzles operating. Blue is constant rate, just the lower nozzles operating, and the gray is the variable rate. So that's the setup for the next several slides. And if you look here at the percent mortality, variable rate had just 7% mortality within the production block. We saw no difference in drift locations, the drift location. And then if we look at of the insects that are alive, are they acting normally, or do they act like they're trapped with a leaf that's been sprayed with a pesticide? 90% of the insects trapped with the leaf that was within the row and sprayed in variable rate mode were healthy, behaving normally, whereas less than half of those in either of the constant rate treatments were behaving normally. We didn't see any statistical difference for the leaves that were in the drift location. Looking at how much the spray volume was affected by these, constant rate, all nozzles applied when we did the math, based on the amount we applied, that would have been 4,031 liters per hectare. About half that when half of the nozzles, the lower only, are operating. Variable rate was about a quarter of that. And again, we're just getting that slice of trunk as we go by. You saw that in the video. And then we use those mesh discs to get deposits volume on a per area basis, and then estimate the amount on the leaves. And so you see here a much lower microliter deposit on the leaves from the variable rate than either of the two constant rates, kind of closing that loop. So what we saw makes sense in the insect behavior. It's supported by the amount of pesticide that was on the leaves. And again, no real difference in the drift. So from this more controlled study, we saw that the variable rate technology increased the portion of healthy insects. It decreased the overall mortality. We saw that in the within the block locations, and that makes sense because when the sensor sees that tree, it's actuating those nozzles, and when it's between trees, it's not. So those boards that were between trees in a row were not getting directly sprayed in the variable rate, whereas they were for the other two treatments. I would like to qualify this. We used a very specific sprayer, not what I would consider a traditional nursery sprayer. This sprayer has a less powerful fan. It generates less drift than the typical air blast sprayer with the rear fan and so on. So these results are specific to this sprayer, this system, but we're looking forward to testing last week. In fact, Kyle Fogel was out. We installed the Smart Apply on a Jacto sprayer, much more nursery specific, and we're going to continue on. And I just would like to acknowledge my partners in crime.
So thank you, Amy. We have a small break now to try and get us back onto schedule. Let's have our break till 10:20 today, and then we'll be back in for the next session. Well, if the next session speakers can stick to schedule, we can go to 10:25. Is there a okay, 10:25, be back in here. going to go, do you want the mic back?
But I can do either if you want
Yeah.
to use it first.
Now I'll
Right.
use the,
Okay.
so Jeff, are we looking good? All right. All right, so welcome back to the end of our technology session, and I'm very pleased to present Gwen Holheisel, who's here from Washington State University. She is a extension educator working on commercial tree, fruit, and grapes. And she has focused her work on sustainable pest management and application technologies and serves on several boards as an ex officio member for the Washington Tree, Fruit, and Grape Commodities. And with that, Gwen,
Thanks.
come on up.
Okay.
So she's providing us the extension specialist perspective.
Yeah. So I'm an entomologist by training, but I've spent the past 17 years working with growers on how to adopt precision technology or just how to improve the technology they have in spraying. So for me, when I go through this talk, I'm going to give you an idea a little bit on where we need to be with extension in order to increase technology adoption. So how I define extension, just so we're on the same basis because it differs throughout the United States, but it's need-based research and education with outcomes that lead to socioeconomic impacts. So for me, when I think about it in sprayers, there's obvious things: drift, human exposure, antiquated machines that don't match the canopy, etc. But there were a lot of unobvious things that came about when I started working in this field, and one of which is that nationally, we have a bunch of extension educators all teaching different things, and we didn't actually know that, right? So we were teaching different BMPs. There's, especially in large farms, there's multiple layers of management which conflict in how successful you are in spraying or technology adoption. And then there's generations of limited base knowledge. So that occurs from either somebody who has a generational farm where grandfather taught them what the best management practices were, or you have a whole host of new people coming in and have never understood anything about sprayers. And I spend a whole lot of time educating those folks, right? So we get some base knowledge coming in. So my motto in Washington State, everybody gets bumper stickers of every drop to the crop, but we spent, from 2013 to present, there was a group of extension agents. There's only about 10 of us in the nation working on specialty crop machine operation. This is not to include all the lovely people working on, WPS training and pesticide safety, but those of us who are joining in this group are really looking at specialty crop, how that machine works, and how do we get people to use them correctly. So we developed the spray application working group, and one of the first things we did is we trained ourselves. And we've spent considerable time and money training ourselves. We have monthly calls. You can ask Peter if he thinks they're valuable. He joins them. And then on average, because we trained ourselves, on average each person holds now somewhere between 5 to 15 workshops per year, where some were 1 or 2, right? But if we have confidence, then we like to talk, so we engage. So who is the audience for this science-based education? There's a lot of papers behind this, but are we talking to the owners, managers, operators, or all of them? In general, all of them. So we have for 5 years held simultaneous Spanish and English classes. As it turns out, a lot of the Spanish classes are the operators, a lot of the English classes, full day classes are managers, and a common comment with the operators is that this is fantastic. I'm going to take all this information, I'm going to use it on my farm at home. They might have a 50-acre backyard farm, but they say there's no way that I'll be given the time or resources to do this on the larger farm. So there is some gap from what they believe at a farm level as it goes all the way up, what's going to be allowed, right? I spend a lot of time talking with owners, because it's the owners that ultimately make the decision, but it's the operators who are using it. So how do they need to set up a management platform or strategy, and what are the best management practices? So it's not like which nozzle to use, but who needs to do it, and what does that middle manager's job look like? Then what do they need to practice in an everyday? So what do they need to do for 1 to 2 years? Then what do they do after that subsequently once you have this working on your farm? So these are a lot of site visits and block visits to how owners need to deal with farm management. Extension is not the sole source of education anymore. So I could not do my job without the manufacturers, Department of Ag, commodity organizations. This picture represents 4 separate competing spray manufacturers. They're all in blue. They all look like they're the same, but they really are 4 separate companies, right? So they come to the field days. This is there's pictures like this from California, New Hampshire, Michigan, but they really are invested in the spray manufacturers to come and do better, right? So they come in a non-competitive way. They bring their machines, and but it's also really important that what I'm saying, right, what Dr. Zhu is saying as best practices gets back to them, because they're spending a whole lot of time with the growers, right? So this is an audience as well. Okay, so the spray application working group across, so we have members from California, Oregon, Washington, Michigan, New Hampshire, Ontario, Canada, and we have a new friend from New Zealand. So when we talk or when we do work, I mean, basically, we educate in any format we possibly can. So we do online classes, there's an e-extension curriculum, there's webinars, there's hands-on groups that range from half an hour to 8 hours. They're bilingual, they're individual sprayer calibrations, but does it work? So I actually have data like this. This is my data because I felt more comfortable presenting it, but I actually have data like this from the California extension group had a grant to create an e-extension webinar, and what was their results, but it's the same thing. Extension works. So before you do the work, people aren't doing as great as what they could. But then you show them how great it is, how much money and what the return on their investment could be, and after 2 years, they're still doing basic things that should be done in the calibration, and many of them are doing things that make it even better, that could create a better return on their investment, right? But many voices do lead to a change. So this is an update on we just did a 2020 just in Washington grape survey. We did a 2009 survey of California, Michigan, New York, and Washington growers in almond, grape, and apple. And the predominant technology was axial fan air blast sprayer used in most crops, very few rate controllers, and very few other calibrations. There were a lot of needs that they had, how to use new technologies, basic machines, etc. Now within at least Washington, we see, a decade later, we see a lot of adoption of some directed sprayers. A third of the respondents, and it was a small survey response, but a third of the respondents are now using rate controllers. So that was a big deal. How do we deal with that? That was mentioned, that one of the technologies to make us go forward, but the growers didn't understand what a rate controller did, right? Or how it is worked, or why should I use it, right? But there's a lot of different options that are on the market. So this is good. This means we're moving in the right direction. At least people are using directed, more directed sprayers, or trying new technologies. So I was very fortunate last year. I lived in Europe actually last year on my sabbatic, and so my intent was to visit my European colleagues in Spain, Netherlands, and Italy, work in their labs, and then see why they have more technologies available, why they're more advanced, what's there, what does their educational system look like, etc. So Globally, there is this question of can we engineer our way out of this problem? In EU, you know, for 2009, they had the Sustainable Use Directive, which was more suggestive. It was a direction of where they should go in the reduction of 50% of the pesticide use. It was a suggestion that they needed to change their labels to be uniform across the EU. But with the passage of the Green Deal and the Farm to Fork initiative, it's not a suggestion anymore. By 2030, they are mandatory reduction in 50% of their pesticides, 50% of the loss of fertilizers, not the use, but the loss. So they have high mandates that these farmers have to meet. And how are they going to meet them? But even worse, how's a grower going to show you that he did it, right? Or she did it? So one notable thing in the EU, they have a lot of technologies. So this is a WADC system. So it's a prescriptive sprayer. So it too attaches to any sprayer, uses a prescription map. And from the prescription map, you put in what rates you would like to spray in different areas, and by GPS, it adjusts it. So it's not complex, but it does the job. They have a completely robotic HSS that can adapt. They were putting on WADC, they put on Smart Apply. So here the manufacturer is a great spray manufacturer, and he says, look, I'll take any off the market technology and I'll make it smart, right? They have Munkhoff, which is using Array technologies, and again, they can adjust any control system within here, multi-row, goes over the row in orchards, so that's a pretty big game changer. So now in Washington, we used to only have Smart Apply. Munkhoff is available, Array Technologies is available, Robotics Plus is coming. So these companies are coming to the US very rapidly. In their system, the take-homes, I can say, they have a lot more engineers in a very small, concentrated area working on specialty crop sprayers, so it allows for larger capacity. They have greater regulations that require the growers to say it or to use it. They also they are coming to where they're changing their labels, I believe, to leaf wall area. So they're not looking, that's the first question in all the training that I was out there with them, is I'm gonna go off label rate. It's the first question the growers ask me. How am I gonna go? I'm gonna be against the law, I'm not gonna be on label rate. I can't actually suggest anything below label or over label to be within my standards of the university. So even if they reduce their pesticides, I just have to say, well, that's good, right? So they're looking at changing to an area of leaf wall area as opposed to a per acre area. Okay, so can we engineer our way out of this problem? To me, when I talk about it in extension, this is how I'm breaking it down now for growers. Because since I've been back, I have realized the utmost confusion that is occurring on precision application technologies. So they believe that the technology will do all things, all the way from an electrostatic sucking the droplets back down to the Smart Apply, you plug and play. It's not plug and play. It's pretty darn good, but it's not plug and play. So we look at the sensor and we talk about that. People are using the Smart Apply to look at their bloom densities and change it by that. It's not a bloom density mapper, but do they have the right sensor? And there's 6 to 8 bloom density sensors out there right now, and how do they assess them? And they're all confused. They throw their hands in the air and don't know which one to choose. So then after they do that, I ask them, do you know what your agronomic decision is gonna be? What's your rate gonna be? So if we look at this tree, are you gonna apply 100 gallons per acre, 50, 10? Are you gonna decrease to 100 blossoms per tree? What's your target? What's your agronomic decision? And then I say, so what sprayer are you gonna use? In Washington, we get to start with just the Smart Apply because that's what we have, but all these other technologies are coming fast, right? So for me, when I look at it, I start with this, and this is kind of on the other technology adoptions, but I've always framed my job based on the social science of the diffusions of innovations. There's 5 tenets of it. So Roger's work was like produced in the 60s, and then, you know, many, many iterations of it since. But A grower has to always have some relative advantage to this precision sprayer, right? So it has to be in economics, regulations, worker safety. I focus on the economics and the worker safety, but still if people are in the field, that's still not, it's not gonna stop if there's someone in the field. But we focus on the economics because right now the regulations don't have, except that you didn't drift, there isn't any added advantage to it. So at least in Washington in the application exclusion zone, if you're using any air of any air assist, even if you're using a directed sprayer that would reduce drift or you're using anti-drift nozzles, they still are at a 100-foot application exclusion zone. So for them, there's no advantage. So everything comes back to economics, right? In the compatibility, that's the second tenet. Will they adopt it? So if we ask these questions, why won't you go with it? It always comes back to one of these 5 tenets. So one of them is compatibility and guaranteed for me to work on a farm or use a farm or them to adopt something on it. If it fails, it failed somewhere in here, right? So this year, I'll give you a very quick example. We were looking at using the John Deere Ops integrated with a Smart Apply and a Blossom thinner or a Blossom map. And how would we reduce it? And I had 3. I had the regional manager, I had the owner, the regional manager, and the block manager all tell me how their sprayers were calibrated, what was supposed to be put out. By the time we got down to the operator, it was 100% different, right? And some of these answers were different from each other. There's too many layers, and we have to work on that because that is critical because a big farm, they're running everywhere, and a big farm can't get down the chain, right? So we won't solve it until we figure out how to solve these operational issues. So complexity, so I've always heard them say no more than 5 buttons and a reliable dealer. That is the #1 in all the surveys we've done. Why will you adopt something? Who is here that's gonna get me those parts? Who am I gonna call, right? And they have to have trust, and that's just a relationship issue. So finding your partners is really, really important. And you know, the initial discussions on Smart Apply looks like it doesn't have any more than 5 buttons, but I'm really seeing how people are using it wrong, or they're using it in a way that is less optimized. So we should teach them that there's more optimization that can be done in that. So for me, this is where these tenants, I really feel Extension has a strong role. I feel like the manufacturers can have a stronger role in this complexity and those other aspects, but the observability, so how tangible benefits are easily observed. So sometimes they're not always understanding if I'm using this variable rate technology and I add it with this other sensor, or if we do these things together, how can we see it? And then triability. So I cannot stress enough, so most of the Smart Apply research, including ours, is done with it optimized. We do it 1 time or 2 times or 3 times in a season. There is nothing like building trust in a system like giving it to someone all season long, right? And so we learn, right? We learn how they're using it right, how they're using it wrong, what happens, how did it fit into a farm operation. We also learn benefits we didn't even understand or know about. So this past year, we used Munkoff all season long in a spray operation and had no idea that we needed to change a system for how it was running its GPS to adapt it from one row to the other and how their driving directions would go. Would never have occurred to us, but we gave it to them all year long and they used it. So there's famous stories about the John Deere auto steer that it really took on, they say, after some all-season on-farm trials where growers started to actually see it. So in the observability and the triability, I use these. This is also the original paper, but for me, I say, look, all these technologies, pulse width modulation, that started 30 years ago, right? You know, the people working on that are now retired when they first came out with it. We're just now 30 years later seeing that benefit. So when I look at this, I say, okay, this isn't new. What we have to do is go back and look at this wealth of research, almost like, you know, a research paper a review paper and pick up what the giants have already done in the research. We're standing on the shoulders of the giants. What I have to do is translate it. So it's new to growers, but it's not new to the science. And then this, we know. So I think this was points of this were kind of like someone mentioned, I think it was Amy mentioned, somebody did it wrong or they didn't like that technology. We see that. This is population dynamics of how technology is adopted, right? There's innovators, early adopters, early majority. This doesn't change, and it doesn't matter any technology, right? This is how it is. Where we can deal with it is that we understand, at least on some farms, there's cost minimizers, you know, where you're trying to reduce costs as much as you can, right? But there's also profit maximizers. So yes, they take the price, but one way they can deal with increasing profits is if they spent more money, they can get into a market that has that higher price, right? So if I can figure out where they are within here, I can affect, with observability and triability, looking at this market share is the only thing I have a chance to affect. How fast can we adopt a new technology because I put it into the hands of growers and we're all telling each other the same message and we're all having the same information. They will always adopt it in this curve. It's just how fast we go through that curve, right? So in summary, for me, educators need trainings to become experts. I'm in this new world of AI and I'm on 2 AI grants. I don't know hardly anything about the science of AI. How am I going to have to educate other people on the science of AI, right? So we have to become experts, and we're far under capacity in the US. Education works, but it's not the only solution. There's a lot of technologies that, precision application technologies that are going to engineer our way out of some of these problems, but they're complex. They have sensors, decisions, new machines. So we not only need to understand how to educate them to use it, but they've got to educate how to fit it into their farm ops, because that's a key component for their success, so they don't kick it to the curb and say that technology did not work, right? So for me, technology adoption is predictable, but centering the research and extension around the 5 tenets increases my success, right? So if I can understand from the growers what they're failing within this and how can I actually increase their triability of each of these and go after grants that increase their triability, then that allows, and I get early innovators to try it, to then speak in this peer-to-peer network. That helps a tremendous amount, right, in the relationships. So with any of these, we must have intimate knowledge of the precision sprayer, the farm operations, and the economic risks for growers in order for it to get adopted. So with that, there you go.
Thank you. So thank you very much. Our next speaker is Todd Gentry, and he is with, so he's the director of production with Cherry Lake Incorporated. Been there 21 years now and a proud graduate of North Carolina State University. So go Wolfpack there. And he'll be talking to us about key considerations for adoption of precision application technology from a grower's perspective.
All right. Everybody hear me? Okay, thank you for that introduction. As she said, my name is Todd Gentry. I'm the Director of Production for Cherry Lake. And really excited to be here and really appreciate the opportunity to come talk to you guys a little bit about, from the grower's perspective, specifically a specialty crop grower's perspective on what it takes, what's going on in our mind, how we adopt or don't adopt, or whatever the case may be when we're looking at a new technology or a new piece of equipment. So before we get into that, a little bit about our company so you understand where we are and what we do. IMG Enterprises is our umbrella company. Underneath IMG Enterprises, we have both Cherry Lake and IMG Citrus. We're family owned and operated. How do I move forward here? There we go. So we're a diversified agribusiness. We're family owned and operated. We have roughly around 630 employees. We're farming around 14,000 acres, all in Florida. Basically from central Florida is as far north as we go and south of there. IMG Citrus, leading producer, we focus on the production, the growing of the fruit, the harvesting, the packaging. We have a packing house, and then the marketing of our fruit, whole fruit, specifically grapefruit and oranges. And then you have Cherry Lake. So Cherry Lake's focusing on ornamental production of ornamental trees, shrubs, and palms. Most of that being our trees and shrubs are all containerized. We also have a landscape construction division where we install our products, and a landscape maintenance division where we can then maintain those landscapes for as long as we have the contracts. We're completely, in both companies, vertically integrated, which helps us to control the quality from start to finish. Here's a map of Florida, kind of showing you where all of our groves and our farms are located. So roughly 1,600 acres of the ornamental trees and roughly 12,000 acres of citrus. Okay, so key considerations for the adoption of precision application technology, the grower's perspective. So for me, when I think of this, the first thing that you have to have, I think, is the correct mindset and the culture within the company, right? The grower has to have the right mindset, the company or the farm needs to have the right culture to be able to want to introduce or want to adopt new technologies. You've all heard this saying before: if it ain't broke, don't fix it, right? And that's kind of how it is with a lot of the farms out there today, where it's, hey, my dad's done it this way, or my grandfather's done it that way. It works, like this is how it works. Like, leave it alone, don't mess with it, which is fine up until there's something happens and then you have to change. So what we prefer to do is to change before we have to. We have this saying, we took that same saying, if it's not broken, break it and make it better. And that comes straight from the owners of our company, and it's ingrained into our organization that we want to change. These are actually posters that our marketing department has put together, and when we hire a new employee, they choose from one of these posters, and there's a couple others too, that they can put into their office. So we really try to drive home that culture throughout the organization. So once we're out there and we do, we have the right mindset, and we find a piece of technology or something that we're looking at to evaluate, the very first question that we like to ask is, does it work? I'm not really worried about how much it costs at that point. The very first thing is it's got to work, and the proof is in the pudding, right? So a farmer wants to be able to evaluate that piece of equipment or that technology on their farm so they can really understand, put it through its paces on their farm, understand evaluate the efficacy. So does it work on our farm? Every farm is different, especially in you'll see this reoccurring theme throughout this presentation, but in the specialty crops, when I'm talking about ornamental horticulture, every farm is set up differently. Our row spacings are different, or single row, double row, triple row. There was a presentation earlier, I think it said 6 rows deep, so they're all different. The terrain in Central Florida, you think, oh, Florida's flat. No, in Central Florida, we're in the hilly part of Florida, and then we have a lot of sand, and it's a rough environment. It's very high humidity. So the best way for us to be able to understand this equipment is, and to trial it, is to get it on the farm and do a demo at our place. And then preferably we want to be able to demo that and try that piece of equipment out for an extended period of time. So the longer the better. The more we can put it through its paces, the better off. And then preferably we want it for free. We want that demo for free because we're farmers. I know that's a lot to ask for, but it really does help us to really get to the heart of how these technologies and these equipments can work. Second best thing would be for us to go to someone else's farm, see it operate. Maybe someone that's purchased it, a farmer down the road or in another state, or maybe the vendor or the manufacturer doing a field day at someone's farm. That's a good first step as well, to go check it out. There's also rental agreements, which we've done in the past, and it's just another way to be able to get that piece of equipment or that technology on your farm and really put it through its paces. In the initial steps, videos, testimonials, those are good ways for us to research and kind of start diving into it, but it's definitely not enough for us to make a major purchase off of. Some of these pictures down here, doesn't show up very well here, but this is actually a southern magnolia where we put some dye into our sprayer, sprayed it out there, and it went out at night, and with a black light you can really see the coverage of how good of a coverage got. And then obviously you have the water sensitive paper that we can use as well. Just ways for precision application technologies, ways for us to see, are we getting the coverage that we need. The next thing is, does it solve a problem, or does it add value? Are we reducing labor, are we reducing inputs? Is it increasing quality, or at least maintaining the same quality? And then does it align with our company's strategy, mission, vision? Like, is it helping us get to where we want to go? Because it can be a great piece of technology or a great piece of equipment, but if it's taking us down a road that's not moving that needle towards where the company wants to go, then it's probably not worth it. So once we have all those things kind of identified, and we've been able to demo, we've been able to trial it, we've been able to collect some data, then we can start asking the question of how much does it cost. We're looking at for our return on investment there. And of course you have the upfront initial cost, which is pretty obvious, but then there's also a lot of times there's annual subscriptions back behind that to keep the data fresh, and then you have the annual maintenance as well. There's replacing wear parts or other fees associated with the maintenance, and then there's additional costs, and these are the ones that are hard to find. Is, do we have to change anything on our farm, infrastructure or staffing wise, that it's going to take up front for us to make this piece of technology work? We've had that before with these little robots down here that we had to change. We were going to have to change all of our system layouts, all of our irrigation, the way it was laid out, and which is fine, and we're willing to do that, but we need to just know those costs up front, right? So you work that into your ROI analysis. And then one of the hardest things, how much does it save, right? So again, where the demo is going to come into play is so we can really gather that data of how much less labor it's going to take, or how much we're going to save in materials or risk, and all the different things associated with that. On the lifespan, so one of the hardest things for us to try to calculate, especially with new technologies, is how long is this going to last? And that's typically because they're brand new. There's not a lot of history there. So we can only take the word of the manufacturer. We can make our own conclusions through our own testing and kind of just a feel, but it's a gut feeling of how long it's going to last, especially when these new technologies are out there in a farm environment with it's very, very dirty, high humidity, you're exposed to the elements, and you have a high-tech piece of equipment. Those two don't always mesh very well together. So we got to make sure it lasts for the longevity of the ROI. So in our company, we use the 3 years. So if it's going to pay back within 3 years, we're going to go for it. 9 times out of 10, or probably 10 out of 10, we're going to move it forward. But if it's more than 3 years, we're going to continue to evaluate. Not saying we won't do it, but we're just going to keep asking questions a little bit further. Other considerations, and this one is probably almost just as big as an ROI itself, is who's behind the product, who's manufacturing the product, and then who's our vendor. Who's going to be our direct line of contact for any technical support. Are they local? The closer we can get them to our site, the better off, because we feel like we're going to get better technical support and customer support. What's the company's size and age? How long they've been around? The part availability. Where can we get parts? Where are the parts manufactured? What's the lead times? How often we're going to need them? These are all questions we start to ask ourselves. And then also we're going to be looking at the entire market in general. Who's the industry leader for this product? Who's the competitors? Just trying to understand the market. Same way I'll shop for anything in my house. I'm going to really try to look around and try look at all the different options that are on the table. Testimonials. At that point we're going to be looking around to see if we can find out someone who's already has it out there, whether it be in our state, in our country, somewhere in the world that we can talk to that's tried this out. And we're not just going to be asking questions about the product. We're going to be asking questions also about the vendor and the manufacturer. So some of the challenges, we've heard quite a few of these today, but one of the first things I'll talk about a lot is the row crop versus specialty crop and the availability of technologies. For specialty crops, it's not as available. It feels as though it's not as available as it is for a row cropper. With a cornfield, everything's a monoculture, usually in squares, planted at the same row spacing, usually the same age, within the crop. When it's with an ornamental tree farm or specialty type crops, these are all pictures from our farm. You can see we got a lake there, all the different shapes and sizes of our sections. The ages within the section are different. Crop species within the sections are different. So all those things make it difficult to find the availability of an actual technology. A lot of times what we do is we look for technologies that's meant for row crops, and then we bring it in. We have our own welding fabrication shops and people on hand, and we try to fabricate it and modify it to make it work for us. We already talked about all farms are different. Staffing. So something else that's can be a challenge with these new technologies is finding the right person on board. And I'm not talking specifically the guy in the tractor or in the cab, but you need someone outside of that. It's either leading that department, whether it be your plant health spray department or in your shop. They need to have both a mechanical mindset and a technical mindset, because those two are starting to mesh. And so it's a higher level person that thinks a little bit differently. Lucky for us, we have that guy on board, because I can tell you if we don't, if it was left up to me or to some of my other guys, it was probably, we would use it until it doesn't work anymore, and then we wouldn't figure out how to use it anymore, and it would just collect dust in the corner. So having the right person on board is critical, I think, to the success. Again, going back, proof is in the pudding. That's very difficult for us. It's hard for us to get good demos. A lot of the times these new technologies and this new equipment is on the West Coast or in the central U.S. hasn't quite made it to the east yet, or it's in another country altogether. So as this technology is developing, getting those availabilities closer to the growers has been difficult. And in general, growers are skeptical that less is more, or at least less is the same. And that goes back again to getting the demos, and they got a lot at risk. This is their crop, this is their livelihood. So a lot of money out there at risk for them. And so they're not going to just jump right on board with something. We have to prove it to them. They have to see it. Initial high price tag, a lot of people may not have the capital up front to be able to put into something like this, and it's not a very straightforward ROI calculation. There's some assumptions that need to be made and good data to understand how to do that. And there's a ton of other challenges. I'm only hitting on the very beginning. So I thought I'd go through, this is how we adopted the Smart Apply system by Smart Guided Systems, which was recently purchased, I guess back in June by John Deere. So, and I kind of laid it out, kind of going through the thought process of just like what I just went through here. So starting with the culture, part of that is being involved in the industry, being out there in different, and being out there to look and getting out and about. So I'm part of a group called International Plant Propagator Society. That is that's an organization within our industry, and it's very good. We're in the Southeast Conference, and so we move around each year from state to state and hold this conference annually. And during that conference, we go out and we visit other nurseries, and that's to me the best way to learn. Is I get out there and see what other farms are doing. So in 2018, I was in Tennessee. Amy Butcher was there, and we were at Helen Hines Nursery, and we were Smart Guided Systems was there, and they were demoing this product, and it was the first time I'd seen it, and I knew right away. It's like this was designed for specialty crops. Like finally somebody did it, and so I said we got to have that, and so the next year. Fast forward, a few months, and with some back and forth, we got them down to our farm and got it installed. We were the first people in Florida, early adapters, to get this installed on our sprayer. There it is. There, that's our shop and our sprayer, airbrush sprayer, and they came out, they put it on there, and they gave us a 6-month money-back guarantee, which took all the risk off our plate. And that is, to me, that's critical, to have that. And it showed me that, okay, they stand behind the product. They have something that works. They're ready to put their money where their mouth is, and I have no risk. I have nothing to lose. And we got plenty of time to really to evaluate it. So that's what we did. And so we were able to see quickly that it had a payback way less than a year. We were saving 40% on chemicals easily. I think that could go up, and as Gemma said earlier, it depends on how full your nursery is and what you're growing, but that can range. And then we were able to save, to understand that we've saved at least a third in labor, and that's really when you're spraying. The only way you can get more efficient, typically, because you're kind of regulated to how fast you can go, is in your mix time. Can you get your tanks to go further? And so we're mixing less often. Our tank, our 1,000-gallon tank or a 500-gallon tank is going much farther than it had previously because we're putting less chemical out, which means our operator is mixing chemicals less often. So on top of all that, just a little icing on top is we got cost share funding, which really made it a no-brainer. We got our water management district paid us 75%. For every dollar we spent, they spent 75 cents to get this, and so it was less than a 1-year payback without that. With that, it was obviously it was months. So we bought 3 of them. And then the product longevity. Dr. Zhu and the USDA have been working on this for a long time, 10 years in the making, and that really showed us that they've already worked all the bugs out. It's been there. It can last. So that really helped us to understand that part as well. Vendor support, Smart Guided Systems has been excellent from the very beginning. There's a guy there in their office, Gary, who's super knowledgeable. we're on a first name basis with him. He helps us out tremendously, and I can't say enough for how well they've been for us to keep this technologies running for us. So at the end of the day, it checked all the boxes. Our company has been really focused on sustainability in more ways than just this, and regenerative agriculture in general, and then safety. Obviously, where our nursery is located, we have houses coming in by the hundreds all the way around. I mean, we're in Florida. Somebody said there's 1,000 people a day moving to Florida. They're moving right beside my farm, it feels like. And so that's been big. It's also big for, we're 1,000-acre farm. We got hundreds of people working out there, and so the spray drift is very important to us. And so that was, and then the ROI, reduced inputs, reliability, and support from the vendor, all that made it a no-brainer for us, and that's why we moved forward. So with that, I'll just leave you with if it isn't broke, break it and make it better. All right.
Well, thank you very much, Todd. Our next speaker is Meg Hathaway. She's with the EPA as a senior regulatory specialist. And she works in the herbicide branch of the EPA and has been working with evaluating a number of different pesticides as well as drone applications. And you'll be now speaking to us about what's new in regulations.
Thank you.
Yep, are you there?
All right. Hello, everybody. As was mentioned, my name is Meg Hathaway, and I'm representing US EPA today. So to start off, I think the overarching theme of this presentation is things to keep in mind about how EPA thinks about precision agriculture and about similar technologies. And one of the most fundamental things to always remember is that in my office, we are always mindful of the laws that both define the mission of our office and provide parameters for what we can and cannot do. So here are the laws. I think most of them should be familiar to you. Most recently, there's been a lot of activity, as was mentioned earlier, in the Endangered Species Act space, so that's something to keep an eye on. Also be aware that our office has had to put a lot of resources this year into coming into compliance with PREA 5, the most recent iteration of the Pesticide Registration Improvement Act that came into effect fully earlier this year. Secondly, some overarching themes into how my office does things. We are a licensing program. Unlike other portions of the EPA, our office regulates pesticide products, not pollutants. So we do have policy documents that we put out quite regularly, but oftentimes where the rubber really meets the road in terms of my agency's actions, it's the individual pesticide products, and any policies we develop would feed into those individual actions. Again, the two main statutes that we have, FQPA and FIFRA, there's a blending of missions and perspectives within those different statutes that we have to balance within the work that my office does. So FIFRA, of course, is a risk-benefit statute. The other statutes that we follow are based on the risk side. So that could be human health, it could be environmental health, depending on which of the statutes you're looking at. And of course, the environmental side of things involves the Endangered Species Act. We have a strong authority to collect scientific data. Data always informs the policy decisions that we make. And then finally, it's good to remember that states are the primary enforcers of pesticide labels. So we really try to work hand in glove with our state partners. That also comes into play when we work with the regional offices of EPA, although the pesticide labels are determined by the headquarters office. So considerations for new technologies. This is kind of an overview of this presentation. You'll notice that the second item is the drone applications. I want to acknowledge up front that some of the slides in this presentation do describe drones. The purpose of that and the purpose of this meeting is that within the thinking of the Office of Pesticide Programs, there's, I think, a larger umbrella category of emerging technologies, of which precision ag fits in, into which the drone stuff fits in, into which various hardware and software updates of other kinds in the agriculture space fit in. And in terms of the recent work that EPA has been doing, there's been a lot of attention around the drone situation in particular. And although that is not the exact topic of today's meeting, the thought process of how EPA has recently looked at the drone applications is, I would argue, very transferable to our current thinking on precision ag. So I'll try to make some of those connections as I go through, but that's why you'll see that content there. So I'll go on to the next slide. A lot of the thinking around these types of emerging technologies have been formalized by recent work in the PPDC Emerging Technologies Work Group. This work group specifically has been sunset, as is typical for PPDC work groups after a certain length of time, but it's been very impactful and has had at least two major deliverables that continue to inform EPA's thinking about these technologies. So the first one I would point you to is the 2021 final report. The big theme in that document is, what is the universe of these emerging technologies? Some of these technologies EPA's known about for years but hasn't really seen that much action on. Others were entirely new to our office, and we just wanted to understand at a very fundamental level, what even are these? What should we call them? The last thing we'd want to do is put something on a label that, you know, is either inaccurate or gets out of date, you know, 2 days later when somebody updates their software. The next deliverable that we had was the 2022 document that describes the drone application. So this is kind of like a white paper that looks at some revised charge questions specific to that type of emerging technology. And again, a lot of those questions about what are the remaining uncertainties, what are the risks and benefits, have some transferability to other areas of the emerging technology space. So just to very briefly highlight some of the major categories of the emerging technologies that were discussed in this work group. We have both hardware and data analytics or software type updates. So of course, physical devices, sprays, nozzles, various types of ground robots doing precision ag. We also have all of the software behind these systems, both types of technology having their uses. And then getting a little bit more into the nitty-gritty, we have some of the themes that have been described today, you know, pulse modulation, various targeted spray technologies, rate controls, GPS type things, spot farming. So just a lot of different technologies out there. Some overlap within the same rig, others are more unique. But just to kind of put up for everybody to see, EPA has heard of these things, we're thinking about them, they were discussed in this work group. So moving along to the regulatory considerations of what we might do with this knowledge of what these technologies are, how they're evolving, what they're becoming. So EPA really needs to understand the exposure and potential risk to humans and the environment of these applications of pesticides with emerging technologies. Specifically, we really want to have a lot of data that involves identifying the relevant exposure and transport pathways. Human health is a big part of that. These occupational, the applicators for these technologies, there might be scenarios that are slightly different. Maybe you have a closed cab, that's pretty standard. Other times the nature of the physical technologies themselves create new patterns of behavior than we might have seen in previous situations. So understanding those types of things, as well, of course, the residential and dietary exposure pathways, is very much of interest to EPA. We also always want to keep in mind what's happening to non-target organisms in the general environment. So that includes both animals and plants, exposure on the fields, adjacent to the fields, terrestrial environments, as well as aquatic environments. We want to be sure we identify parameters relevant to the technology that can influence exposure. Some of these machines have application parameters that are unique to them. We may not have seen them. Others may have variants of technologies we've seen before, but have their own unique specific considerations that should be taken into account. We also want to understand how exposure and risk relate to EPA's current risk assessment methods. I know this is a topic of great curiosity. I will say that at this point, generally speaking, EPA is not focusing on revising its risk assessment methods. We are, however, in more of a paradigm of looking at mitigation potential credits, more or less. So I think, if there is more data, that would reopen the conversations for the risk assessment method updates, but we are not there at this point from EPA's perspective. We also want to be developing common practice and standards for the use of technology. So I was very encouraged by the presentation earlier today talking about standard development. One of the challenges EPA continually faces with not just emerging technologies, but any technologies in the pesticide space is that different people use different language for often similar things. Sometimes they use the same thing for entirely different things. We want to know what people are talking about so we can put that on a label that everybody can understand, that can be followed, that fits the law parameters and is enforceable. Finally, we want to be sure that there's a development of an EPA regulatory framework to support these technologies. We think innovation is great. We want to allow for space to have these technologies flourish and succeed. That said, we are constrained by the laws that we work within, and we also want to be very cautious to not put preliminary language out onto labels that inadvertently hamstrings innovation by locking people into a specific type of technology. So for example, one potential case that was floated is, if we had a requirement for a particular type of robotic eye on an application technology, and then a week later there's a new version that is entirely different from what we just approved, but is efficacious, does all the good things we want it to, then either my office will have a huge leg trying to update labels, which, as you know, we are constrained on resources to do, or we might inadvertently reduce support from a promising newer technology. So getting into the drone slides, one thing that applies to all these emerging technologies is that EPA does not have established policy regarding pesticide applications, data requirements, or implementation on pesticide labels at this time. I've worked extensively on the drone issue, so if you have questions specific to that and how it might relate, I'm happy to talk after this presentation. But I think the main posture is we are not at this time proactively on labels putting language that is specific to the technologies, but we don't want to discourage it. So we're looking for middle ground strategies where we can either give credits to things if they meet certain standards, if they meet certain definitions, or have space where we at the very least do not prohibit the use of technologies. And some of the considerations that would apply to precision ag as well as the drone situation is what are the compliance issues we might face? So for example, if you have technology that has different definitions of boom width, or if you have something where the technology reporting requirements might differ between the different machines, those are something that would need to be taken into account. The data needs and requirement, again, that goes back to what are the effects of these technologies to applicators, what are the effects to bystanders, what are the effects to general wildlife. We also need to be sure we understand the drift and safety considerations for any new technology. Any new technology has a potential to have new pathways. Hopefully with the precision ag space, there's an overall reduction, but one of the obstacles that we face in terms of thinking about those technologies in EPA is if the reduction in pesticides per a given field is dependent on weed pressure, there's no guarantee that any particular field has a set baseline of reduction relative to a broadcast application. And unfortunately, that leaves us in a space for our modeling where we say, well, the worst case scenario could still happen. So just to give you a sense of that thought process, we understand that there's incredible promise and in many cases, case studies already coming out on the potential for these technologies, but because that performance is not inherently universal by just the use of that one piece of technology, it makes it a little more complicated in terms of how we consider it from a regulatory perspective. Moving to the next slide. Some other considerations in terms of points that we want to have future engagement on for precision ag. would include, again, the exposure modeling, drift modeling, what types of residues are left in fields, as well as just the overall efficacies of these technologies. As was so beautifully put in one of the previous presentations, do these things even work? We always want to have that be in mind before we go through the whole process of giving any credits to one of these technologies. And to keep these themes in mind, OPP is in communication with a number of other regulatory entities. Again, the work group, but those conversations continue in various capacities. Surveying about the use of technologies is also an important feature. I was very appreciative of the USDA presentation earlier that talked about some of the precision ag in-field applications. I think the big takeaway from this slide that's more specific to drones is simply that bottom question, and interest in these types of technologies is growing and growing fast, and EPA is aware of that. So in terms of the uses, I'll skip that because I think that's not as pertinent to today's conversation. But to get back to some of the overall regulatory things that EPA is thinking about, as was mentioned, there has been a lot of movement in terms of ESA compliance within the Office of Pesticide programs within the last few years or so. We do have our ESA work plan, and then we also have a couple of documents that have come out even more recently. So the Vulnerable Species Pilot Program was mentioned. If anybody's unclear on the timeline of these things, so that one already went through public comment, has been finalized and is out in the world. The herbicide strategy is one that is currently being released for public comment. We had the original public comment close, but as you might guess, this was a topic of intense interest, so the comment period was reopened, or extended rather. It ends in October. Amy, do you remember the exact deadline for the? Okay. For the herbicide strategy? Yeah, I think it might be on the next one. October 22nd. Thank you very much. So you have until then to submit your comments on the herbicide strategy, and that is posted in regulations.gov. The future of where this type of thinking on ESA is going is, at least in one aspect, going to be on regional plans. So for example, one thing that is under development is addressing listed species and designated critical habitats in Hawaii specifically. Hawaii, of course, has a huge number of endangered species and has very unique topography. So that's an area that we are trying to have a regionally specific plan developed. Okay. In terms of if you are getting new studies or data on precision ag to the Office of Pesticide programs, the first thing to do is look at the existing guidelines we have. They may not fit exactly what you want to do. In fact, by the nature of being emerging technology, they probably won't. But you want to at least see what has been done, understand that, and see if what we have out there already can be a model for developing new protocols for testing. Some specific things that we've done in terms of other labels for thinking about mitigation to give kind of a credit for some of these newer technologies. We think it could be useful if there's a reduction in how the impacts of things like wind speed, temperature, relative humidity, and those other variables help reduce spray drift. If there's potential for reduction of erosion, that's also very much of interest to EPA. And we want to see data that shows how these new mitigations, how these new technologies can be implemented and how effective they are at reducing off-site movement, as well as how they support any changes in efficacy. So some, again, to repeat from the last slide, spray drift and runoff reduction are some of the major themes. Use of hooded sprayers, for example, may be something that is useful for the spray drift. One thing I would emphasize in terms of looking for some space for mitigation credits for your particular technology, make sure it's appropriate to the type of risk you're trying to reduce. If you are in the hooded sprayer business, if you have a proposal for drift reduction, that sounds very feasible, let's talk. If you are trying to use that same hooded sprayer to reduce volatility, that's not going to change the inherent chemistry of the pesticide product. I would have a very different conversation with you about that submission. So again, the first place to look is the existing guideline studies. This slide shows an example of a spray drift test guideline that we have. That's posted on regulations.gov. We also, if you do some Googling, have a lot of guideline documents posted in section 830. And that's, I think, all I need to say on that slide, so I will continue. And then just to kind of come towards a conclusion, we did want to emphasize that we're working with a large number of other organizations and stakeholders to keep these conversations going. So we have APCO, we have SPIREG, we have OECD. We've been working with a lot of different industry task groups, CropLife America, and of course CIRSA today. And we're also open to being approached by others who might want to begin a conversation with us. So we're trying to keep these channels of communication open, both domestically, internationally, within various public and private partners, and want to hear what others think we might need to know in order to have the best pesticide labels we can. So to summarize, my office continues to work with various partners on emerging technologies, and in order to consider emerging technologies within a regulatory framework, EPA needs to understand how these technologies may reduce or increase risk compared to current technologies, what factors related to the technology influence the potential for exposure, what standards are being referenced for the use of technology, and finally, how that might feed into an EPA regulatory framework to support the use of technologies. And that concludes my remarks.
So thank you very much, Mick. Our next speaker is Dr. Bernie Engel, coming in now. So Bernie is a bio and ag engineer, a professor of bio and ag engineer. He's also an associate dean and director for the ag research and graduate education at Purdue University. So he's been a leader in national efforts to integrate GIS and information technologies into watershed modeling. And today he's going to be sharing with us site-specific modeling for risk assessment and mitigation.
Thank you.
Thank you very much.
I think this talk follows nicely from the prior talk that laid out some of the regulatory landscapes. So let me see how we might think about addressing this. I've been doing hydrologic water quality modeling, fate and transport modeling of pesticides, nutrients for many, many years, have worked with a wide range of models, and it's really interesting. I'll come back to something here today that was really work in conceptual thinking that began more than 50 years ago at Purdue, not by me, some predecessors, that worked with EPA in thinking about targeting where nutrients were moving, where erosion was occurring from, in the northeast part of our state. So, some of these things have come full circle with changes in technology and approaches that we're talking about today. I don't think I need to probably dwell on this slide. The morning has really set this up about the opportunities for precision application of pesticides, and so I think this has been well covered already this morning. So the bottom one, though, is probably a relevant point here, that as we begin to think about potential impacts of the technology on fate and transport of pesticide products, it's a game changer there as well. And we've not talked much about that today, more drift, more total application rate, but where these products ultimately land and then move off-site are incredibly important. So how do we begin to think about changing the way that we approach that? So I'll try to provide at least some thought-provoking ideas here, and certainly many ways this might be done. If we think about the current way that US EPA goes about assessing movement, fate, and transport of pesticides in water with soil erosion, they use an approach that is largely compatible with where we're going to go here a bit later. So they take things that impact movement of pesticides, so climate in the top little grid here, followed then by soils, by land use, intersect those, and then run models against those unique combinations. So then, if we see in the top box, the square to the right, we begin to get combinations of these things that can then be modeled with a model such as PWC with other models that EPA uses in these fate and transport kinds of efforts. Those provide series of outputs, additional work done then in subsampling these and picking out ranges in which decisions are ultimately going to be explored. But this framework, in thinking more spatially, begins to set the stage here. Certainly there are opportunities when products maybe don't pass some of these earlier screening stages to move more toward descriptive approaches of local details and increasing levels of detail to continue that assessment approach. So again, what we'll look at certainly would facilitate that. So what are some of the challenges of some of the approaches in use at the moment? So again, being conservative and then moving more toward higher tiered assessments. Initially, some of these don't maintain the levels of detail on land use, soil, slope, other things that we know would impact fate and transport of pesticides. So some of these get lumped together in various ways, and certainly they're somewhat conservative in selecting not only the 90th percentile, but that 90th percentile in reality is coming from worst case combinations, which in reality and within a field or small watershed or big watershed are often combined with many, many other combinations that would be at lower percentiles. So again, early on, certainly very conservatively assessed, and rightly so. The one that is quite significant based on today's conversation is really the second bullet item here. So this idea of a uniform at label, at maximum number of applications typically, applied with no consideration of variability spatially of those products. So again, a very conservative approach in these early assessments, and that today, as we're talking about, is substantially different than the assumption made here. So we'll look at some opportunities in a moment to think about that. The simple models have limitations as well as models have continued and the science in those have continued to advance. That has also changed greatly over time, and certainly opportunities there. We'll not dwell on that so much today. And again, the big one, this ability to consider spatial crop protection product application is one that we need to be thinking about. So how might we go about that? And again, many models that people work with, I work a bit of an equal opportunity offender in working with models and work with many of those. We'll look at just one of those today. We can certainly capture fine resolution and detail with these, put these together for fields, put these together in small to large watersheds. We'll see that example in a moment. Increasingly in these worlds, people are using parallel computing, high performance computing to model small details, put those together, and roll these up into larger areas. Again, a huge change coming and has been ongoing in that area. These include opportunities to calculate and estimate all the key components in this that would include runoff, erosion, and drift potentially. And so such approaches could be quite helpful as we think about potential benefits in risk mitigation that site-specific or precision applications of pesticides might provide. So sort of back to the future here. So some 50 years ago, we began thinking about how do we best capture spatial variability in landscapes And at that time, grids were a common approach. So begin to overlay grids, begin to then capture unique aspects for each and every grid, model these, model interactions, because things sometimes move across these boundaries, put this together, and we can begin to think about what does spatial variability within this field look like? How would that come together? So if we go back 50 years, computational issues were a huge issue at that time, right? Huge issue. So these sort of went by the wayside. Data to support this, 50 years ago, it was paper maps largely, right? And not very good scale paper maps. So again, something that has changed greatly in recent years and will continue to change greatly as we look to the future with national data sets at high levels of spatial description that begin to support these grid cells, commonly now being at some 30 by 30 meters with the range of data sources that are used. So we'll look at this concept, let's build on that, see what we might be able to do. So a little bit of a cartoon example here, chopping out an area from a watershed that might represent a field. We may have, in this particular case, some a stream running through that to a water body here. A scenario like this would be, with a slight modification, look very much like a water assessment scenario that EPA might use in risk mitigation assessment. Might look something like what's also going on for endangered species assessments when those are water-based or wildlife is coming to water-based areas. So with this, we can begin to capture in each of those grids again the soil variability, the elevation, and therefore things derived from that slope, primarily slope variability. In this case, I'm going to assume that we have a uniform land use here, but you could capture that. You could capture weather variability. We're small here, so we're probably going to assume that away. But you can begin to capture a great deal of variability with these small grids. So in my example that we'll use a bit as a base here to take a look at this, we will not put pesticides along this stream, so we're going to assume a buffer around that, no pesticides there, and 100% rate in all the darker colors on the screen. The red on my screen, they look kind of more black as projected here, but all 100% in those. So if we were to do that and then use an off-the-shelf model for this, and again, a number out there that could do something like this. I happen to use Apex, same science in SWAT that we do a great deal of work with. And what do we get back? We get back variability, grid cell by grid cell, due to variability in soils and slope here primarily, right? So application rate's the same, except along my small channel. Land use, we said that was the same. So the variability that we see in runoff and movement of pesticides here, driven by variability in slope and soils. And to keep this simple, I got rid of units, we normalized these things across these so that we don't have to argue about which pesticide and all those things here. So that is a bit hidden by this approach. So we just chunk those into 5 categories at equal intervals, and so we've got 5 categories. Okay, so we can begin to see that even without variable rates of pesticide product application, we get variability. So now what do you think is going to happen as we move on and begin to add variability? This is going to look even different, right? All right, second scenario, same place we were just at. Now, I've varied pesticide application rate over here. Again, yes, I understand, and this morning I thought did a great job in setting the stage that application rates are going to vary sort of meter by meter potentially in all directions, right? So, if you're turning parts of the boom and individual nozzles on and off, we have huge variability sort of meter by meter. But to keep this simple for the modeling, I said, let's put, 0, 25% of max, 50, 75% of max, and a few cells at 100% of max. That doesn't mean it was uniformly applied. Yes, the model assumes that, but within rounding errors at digits way down the line here, it turns out when we model those losses, my assumption is fine. So again, I would acknowledge, I've grouped these application rates high level in these 30-meter grids, but don't get hung up on that. It's, results are going to look the same with those at 100% and 25% of the grid cell, or 100% and 50 for those that are labeled 50, and so on. And again, I was conservative based on the up to reduction rates we heard this morning. So you can do my math here for me, and if those were all at 25%, I've put on something a little over 50% of max application rate in the entire area. All right, so what happens then in my results? Now I get this spatial pattern. We'll look at masses here a bit later, but I get, again, a different spatial pattern. Again, rates interacting with soils, interacting with slope to give me this. These could be for an event, these could be annually. I think these were actually annually, but again, you begin to get the idea. Let's do another one. So now, same as before, but have re-randomized to some level where these go. And again, on the right, we now get yet a different pattern. And we'll see that we get different masses here ultimately. And one more, just to, now we've got sort of uniform from 100 down to nothing against the stream here. Might be a mitigation measure, it could be other things that we're now accounting for as well. And again, what do we get? We get, yet another spatial pattern with that intersected. Let's put these together and see how they may look. So now we've got, the 4 scenarios we looked at. So the first one up here, upper left, was 100% everywhere except along my channel. So we see that pattern. We see, let's see, 2 and 3. We put on the same amount, but our patterns were different as to where we put them. So we begin to see that. And then the last one, also same amount, but now I had these sort of uniform patterns that we could use somewhat more conventional technology to do those if we were doing that versus the technology we were talking about earlier today. And we can see what the patterns look like there. So again, the take-home point from this is really, we really begin to change the runoff and movement of these products with that runoff, with erosion that might move with these things, and they can be greatly different on these scales. If we look at masses applied across my scenarios, and then masses lost in runoff, again, we can begin to see potential for big variability. And again, remember, I was nowhere near the up to reductions we were hearing about earlier today. So how do we begin to think about this? How do we begin to incorporate this in risk assessment? I think that's the real challenge. Let's talk a little bit about some ideas there. Again, I would suggest EPA, with their current approach, has a base built that could move in this direction, right? So remember, they're taking and intersecting spatial variabilities. They're just not incorporating the spatial variability of pesticide applications, nor potential scenarios for those for mitigation, for risk assessment, or to look at higher tiered kinds of approaches. So how might we think about doing that? I'm going to show you an example here a bit that builds on what we just looked at. We take a land use map over here. Again, these kinds of things available nationally. including crop rotations in these for places where crop rotations matter a lot. Lots of good multi-year data there now in those, so if we need to pick those things up, that could be in this one. We take soils maps, again, available nationally at suitable scales. Both of these at suitable scales to pull out this grid like I did earlier here, 30 by 30 meter grid cells, and we can begin to push that through models. Again, I picked one, could be other models, could even be the EPA's current model would support this kind of work again with additional computational resources, or as a tiered kind of approach when we get to more local areas that could be challenged to meet criteria. And again, just a result here, could be runoff, could be pesticides, could be nutrients, could be other things, but again, you begin to get the idea. So, turns out, is this a pipe dream? No. There's some of us who have been running such models nationally for a while, and I have several other colleagues around the country who've been doing the same. So, the data are here, computational resources are here at some level. The ability to flow data from the definitive sources, USDA for the soils data, USGS, others for some of the land use, crop rotation data that's spatial in nature, weather data, historical weather data, other USGS for elevations, and you calculate slopes, other things from those. So flowing those data into a computational device in which you begin to embed your model and ways to process those data and make it run, and you can begin to do these things. Again, some of us are doing some of this at some level today, but you can begin to think about what might the future look like when you can do this. So, very interesting to sort of think about the future. So, again, how might this play out if this were to be embedded in a system that one might be engaging to understand what does local loss look like of nutrients, pesticides, other things that matter. Again, start with national maps. We all probably use Google Maps routinely, or their competitor Bing Maps that we use less frequently probably. But again, national data sets sitting on that kind of platform, we interact with those pretty routinely now. You build those things into these little tools so that, again, you can navigate very quickly, efficiently by coordinates, by addresses, by however you describe things to get to a location. Get to a location like this. We run little watershed delineation programs against elevation data to get watersheds, small watersheds or bigger watersheds to work with. Again, it can be dynamic. Don't have to do all the pre-computation. So we can begin to get those. And then you begin to chop out all the data nationally that you need. Data flowing in real time to those so that you have the latest data, the most appropriate data. And now the part that's a little more challenging are some of the local, more specific details, right? So which pesticides, timing, how you're managing. Again, some databases that support some general descriptions of these, but again, opportunities for mitigation around some of these measures. And certainly right here, a place we can begin to insert variable application rates of pesticide applications into this. Or, if some of you in the room that are doing work with these technologies have, experiences and have mapped data, again, these could be generic to start with for regulatory kinds of assessments that would represent use cases or ranges of use cases to understand, what is that impact in these. So again, thinking out to the future a bit. And when you run those, then you get all the outputs that are needed for regulatory purposes, for management that maybe you don't have now, but might be useful in many cases around water movement, timing, nutrient movement, pesticide movement, erosion, and so on. not that far away. Some of us have been doing some of these things. We just don't have enough computational power to open it up to you and the world in many cases at this point. So a couple of items in thinking about this a bit further. So as we've heard this morning, it's happening now. And certainly as we think about the future, much more variable rate application going to occur. How do we begin to account for that? Hopefully, I convinced you a bit that there's an opportunity with some of the modeling that's possible today and certainly into the future as we think more about some things that we'll touch on here at the very last bullet here. We can do some of this now, certainly more doable in the future, and it's the same models we're using now. We're just deploying them in a little bit different way. We need more data, yes, and so I think there's a challenge to begin to get data that's that all of us can be comfortable with for some of these uses, that protects the individuals, but provides enough data to begin to understand the true impacts of this as it rolls out and is adopted, and as it changes into the future, right? So I think this is an approach that will play well into the future as well. High performance computing certainly going to be important in this. Some of the runs for these little areas that I was showing you, are on the order of a minute to a couple minutes for small areas if we're doing very many years of computations in those, and you can guess that as this gets bigger, computational time increases linearly at least on these things. So making these things parallel, you can largely do that with this grid approach. Farming these out, as we saw in the cartoon earlier, to many computers, we can get there. So with the revolution we have in sensing that's driving a lot of the discussion this morning, in computing, the same things are going on. In data, all kinds of data, again, huge revolution in all kinds of data that could be used in these, and artificial intelligence in these, huge opportunities to rethink many things that we do, including some of the regulatory approaches around these, and making them much more location and site specific and management specific to your locations. Thank you for the opportunity to be here. So hopefully that was interesting, and I think it touches and it is a good way to incorporate much of what we've talked about today to this point, and how this could influence regulatory approaches as we move forward. Thanks.
So thank you very much, Bernie. I think you do have the speaker system. Yeah. No. So it's my pleasure to be introducing Ramalingam, who is a group leader for application technologies at Syngenta, and specifically working with NAFTA as a group leader for application technologies for NAFTA. And Ram is going to be talking to us today about precision application of pesticides, perspectives from crop protection industry.
Yeah.
So thank you, Ram.
Thank you, Amy. Can you all hear me okay? Okay. Yeah, good morning. I understand I'm the last one between you and the lunch, so let me see if we can speed things up a little bit. And it's also good that a lot of previous speakers have addressed many of the things that I'm going to talk about today. So with that said, let's get right on. It's not clicking. Oh, okay. I was clicking the wrong way. So just wanted to, again, shift our focus a little bit. A lot of conversations this morning had been around orchards, vineyard type applications, and then we also have to think about from a precision application standpoint, there is a lot of evolution happening from a broad acre row crop standpoint too. So from conventional ways of thinking about how to apply inputs and where are we right now, and as Rama said this morning earlier, what do we want to think about as technology evolves, and as a CP product manufacturer and distributor, what are the things that we are seeing in terms of, again, both opportunities and challenges. So a lot of people already know, we touched on it, the differences between conventional versus more of a data-driven farming about use of optical spot spraying, sensors technologies, etc. So for any row crop, again, major inputs are seeds and nutrients and then pesticides, not in that particular order, but most of the time it follows that order. And then we are managing a lot of crops for a grower with 1,000 acres or 3,000 acres. You can think about the complexity that they are dealing with on a day-to-day basis, and how do we bring precision and accuracy in those types of environments. It's getting more and more challenging, even though we have complementary sensors and technologies that do most of the guesswork. But in terms of actuations, where do we apply, how much do we apply, and does it meet the regulatory standards? These are all the questions that we are fielding. So we are shifting majorly from the status quo of managing all the crops as if they were the same to, Garrett was mentioning, we are focusing more and more towards plant level or even leaf level capabilities that we have now. So from at a high level, we touched on a lot of things. Technology is evolving, but the major factors that will influence the adoption going forward would be, number one, we think it's the economics, right? Return on investment. And a lot of people also touched upon, do we have the service? Do we have the support? If things go well, obviously no issues, but when things do get issues that we have to manage, do we have the right resources available then and there? Because agriculture cannot wait. The application needs to be done that day or that hour, and we cannot wait 5 days from then. The diseases and the pest pressure will increase tremendously. So a lot of these adoptions will be driven, and some aspects of farming are more suited for these types of applications. Specialty crops, automation is highly suitable. And large size farms, obviously, they can recoup their investment a lot faster. And weed control is ideally suited because plants don't move, unlike insects or diseases which can spread through the germination of spores, and they can spread rapidly. But plants, obviously, we can use cameras and detect where they are and then go after and hit those. And there is also opportunity in terms of tank mixing, disease control, and insecticide control products with variable rate applications and stuff. So yeah, what do we see as opportunities? And again, when we think about legacy products and then new products, both in the marketplace at the same time, do they all fit with these new types of application equipment? We talked about solenoids, PWM systems, valves, and materials of construction. We go through a lot of evaluations and making sure that the products that we have in the marketplace, the fitness for use, as we call it, is very important. So when the technology evolves from an equipment manufacturer standpoint, nozzles and sensors and actuation systems, and chemistry, from our input standpoint, we have to make sure that they are all compatible. We don't want to deal with a lot of issues that, and then becomes a question mark. Is it a product issue? Is it a software? Is it a hardware? Oftentimes that gets very, very tricky in terms of managing those types of issues, because we just don't have the time to troubleshoot what exactly was the problem, because the growers want the product to work. And targeted, we can use these platforms as well as to think about some of the active ingredients that might not be effective conventionally at very small use rates, but with these site-specific applications, targeted spray, we can still bring those active ingredients to market. And from a cost of manufacturing, cost of supply standpoint, it'll still be attractive to the grower. And the challenges, some of them, again, we talked about value creation. How do we create value? How do we capture those values? And when it comes to efficacy, we do a lot of trials and making sure that our products work. What we focus on is the dose transfer. We need to make sure that the active ingredients are transferred from the point of emission, which most of the time is the nozzle, ultimately to where the disease or the pest infestation is there. So how do we make sure that, with all these UAS types of delivery platforms, precision sprayers, we talk a lot about reducing the volume, but what does it matter? Are we still effectively delivering the active ingredients so that they can do the job? Ultimately, what the grower is investing is they want dead weeds, they want disease-free crops, and they want insect-free, pest-free produce at the end of the day. They don't care about the technology, they don't care about the product. They are investing in making sure that they are getting the crop performance maximized. And a lot of nozzle options, we talked about pulse width modulation. All these technologies hopefully complement in terms of delivering the dose effectively to reach the target and then limit the off-target movement, and in terms of whether it's physical spray drift or runoff and on whatever may be the criteria that we are trying to use. And we also have to understand what might be the barriers to grower adoption. I know Mr. Gentry spoke about some of the criteria that they use from an adoption service, ROI, and stuff like that, and do we have all those available and check those off from an investment standpoint. We talked about, again, differences between green on brown, green on green, so I'll skip this slide. And this is one of the things I wanted to see. If I leave you with a take-home message, this might be it. So we talk about, again, from a weed control standpoint, the importance of using pre-emergent herbicides as well as post-emergent herbicides. Pre-emergent, a lot of green on brown, and then post-emergent, green on green for that matter. So the crop management practices and advice also needs to change with the opportunities to use these types of systems. So here is a simulation just to illustrate the importance of a very good pre-emergent control. So what you see on the left is that when no pre-emergent control is used, then practically you deal with a lot of weed infestation, and these sensors and these technologies, they have to be active 100% of the time. Back to what Garrett and Adam were describing, the effort on the application systems is at that high level. But as you start to increase, and then use full rate pre-emergent applications, then you don't have to fight those weed infestations at the post-emergence level. So a lot of these, behavioral and cultural aspects in terms of understanding what your crop is, how your pest is behaving, whether it's weed or disease, etc., and then what sort of data that we collect to come up with these meaningful and important decision making in terms of what rates to be used, full rate, half rate, quarter rate, etc., and then ultimately how does it drive the performance of these spot spray or see and spray technologies. And again, we deal with this complexity over and over. Sometimes, it's just that we have to manage those fields as they are being sensed, and sometimes, like we talked about, there are some variances even though the machine is programmed to apply, but sometimes the sensing and decision making may not be the perfect level, and some parts of the field might be getting over applied, and some parts of the field may be under applied, and that's a big deal for us. Again, we want to make sure that we are not doing under application, because that has a lot of effect on the resistance, and we don't want to drive the pest resistance wherein you have to come back later and then deal with that emerged pest, or do over applications later on. And how do we sort of think about, we are reducing the volume, but are we still effectively targeting the pest and getting that effective control? And one of our senior leaders used to say, Syngenta is the largest manufacturer of pesticides in the world where no one wants pesticides, right? So again, there is a lot of that opportunity to, again, make sure that we do the things right and we effectively deliver the dose based on the research, based on the data that we have, and then not over apply or under apply that might lead to consequences later. So again, this is just a summary, and it's also good to sort of reiterate what has been already said by many of the speakers this morning. And the CP industry is aware, and we are engaged to meet the growers' needs. And in terms of impacts, effective pest control is what we are after. And there are spray programs, both pre-emergence and post-emergence, that need to change to adapt to the emerging technologies, especially precision application. And then what do we know today about crop safety, about resistance management, and what are the effects of these over and under applications? Then I touched on a little bit about legacy products and new products. Are they going to be fit for use when it comes to these new application systems? And ultimately, one of the adopter factors of adoption is accountability, who takes ownership, who provides the support, and the care when it is needed. And again, during the day and a half, we'll discuss a lot in terms of what is the claim, what is the reality, and from a regulatory standpoint also, can we make things that are more user-centric with the available technology? Can we make it very specific and come up with some apps that could alert them that there is that endangered species nearby, so make sure that you are aware of that and stuff like that. And ultimately, we tried to discuss this already. What does that amount per acre mean, for orchard type application, for row crop type application? Are we still using those criteria and coming up with regulatory framework, or does it need to change? So this is my last slide. And again, the drivers, as we see from a CP industry standpoint, is that economics or return on investment is the main driver for precision application adoption. And we talked about a lot of these challenges, and we need to start thinking about incorporating these new tools and come up with better decision making, and the use of legacy products in these new systems, and then label language. Obviously everybody here knows that label is the law, and can we make those labels less complex, deliver directions for use from an equipment standpoint, from a nozzle selection standpoint, from a product use standpoint? Can we make it a little more easy for the growers and applicators to make informed decisions, basically to reduce the complexity? So from the context of this workshop, I think there are a lot of good discussions already plant the seed in terms of, again, think about the current ways of coming up with decisions, and then what could we use to think about the use of these technologies and the evolution that's happening around us. What should we be thinking for tomorrow's needs? And yeah, with that, I'll stop there, and thank you for your attention. It's been a great pleasure to be here with you all.
Okay, guys, thank you. I'm Carrie. If I haven't met any of you guys so far, I'm sure you've seen my emails coming in over the last week or so. I just wanted to do a few logistics before we eat. We are going to do our group photo out on the front steps because the sun has now come out. And Jeff over there in the back will be getting you all organized out there before we eat at 12:30. So you'll have from 12:30 until 1:30 for lunch in the West Court, which is, if you go back towards the front door, just keep going straight instead of going out the door coming from this hallway. Then if you are one of the group facilitators for this afternoon, we're just going to ask that you come back and meet us out here in the ante room at 1:15, so that we can just have a quick little chat and get everybody organized. If you look at your name tags, you'll notice that there is a colored sticker on each of your name tags. That's how we're going to do the breakout groups this afternoon. And so when you get back in here, we will tell you where to go according to your color. We'll have 3 groups in this room, and then the rest of the groups will be out in room 125, which is right around the corner. I hope you guys enjoy your lunch, and we're really looking forward to some great discussions this afternoon. Laura, did you have something else you wanted to say? Yes. Okay. Oh, yes, that's okay. Sorry. Also, we are going to be putting tables in the room while y'all are eating. So if you don't mind taking your bags and then putting them sort of on the shelf or along the wall, that will help them have the space to move the chairs. So, all right. Well, thank you so much for your participation this morning, and we look forward to some great discussion this afternoon.